Hi, my name is Michael Thiessen, and I'll be your instructor for Mastering Nuxt 3. In this course, we will be coding a course platform as the project. But the focus of this course is on learning Nuxt 3, not on teaching you how to build your own course platform, because I'm guessing that you probably don't need that. But what you do need is to understand the principles and foundations of Nuxt 3 so that you can build whatever app you're working on, whether it's for your job or for a side project or for whatever other project you are using Nuxt 3 for. In order to do this, we start with the code so you can see how things come together, but then we take a step back and I explain how these things work and why we do it in the way that we do it, so that you can come away with a deep understanding of how Nuxt works. There's a GitHub repo that you can use to follow along. It has a single commit per lesson to make it easy for you to jump in and pick up where you left off. This also makes it possible for you to jump around if you want to, but keep in mind that this course is designed to be taken from beginning to end. Each lesson and each chapter builds off of the previous one. So you should probably take this from beginning to end. But if you really need to, you can jump around. And if you have any questions that you need to ask, you can ask them in the Discord server. There will be a link in the description of this video. In the next lesson, we'll take a look at getting our project set up so that we can start learning. In this first chapter, we're going to go from no app to deploying our app on Netlify. In between, we'll learn file-based routing, how to do dynamic and nested routes, and we'll also take a look at how Nuxt rendering works, how to use NuxtLink, and how to track the student's progress through the course using useState and a helper from Vue. Let's get started. Before we can jump into learning Nuxt, we first need to get set up with our code project here. Now, I've been using PNPM to develop this project, and if you want to install it yourself, there's some good documentation on the PNPM website. There are many different ways to install it depending on your system and what you like. So I won't go through that here, but I'll let you figure that out for yourself. It's very straightforward and this documentation is very well written. If you prefer to use Yarn or NPM, that will work fine as well. All of these package managers use the package.json, so they are compatible. The only difference is that this repository comes with a PNPM lock file, but that shouldn't matter too much for our purposes. Once you've got PNPM installed, or the package manager of your choice, we now want to install Nuxi. On the Nuxt.js docs, we see Nuxi being used as a hot-loaded script using PNPM DLX. What this does is it downloads the script and then executes it, as opposed to it being a tool available locally on your machine. This works great, but it is a bit slower, and I prefer to have it installed globally myself. So if you want to do that, you can use the command pnpm install Nuxi and add the -g for the global tag. And then if we run Nuxi, we can see that it's much faster and we don't have any output from it downloading. And as an aside, this autocomplete prompt that I have here is from a tool called Fig. I've been using this autocomplete for a couple months now, and it's very helpful in being able to expose the different options, commands that tools are giving you. Because normally on the command line, you don't know what the different flags and options are, but with Fig, you get to see that there's all of these different options and different things, and you can, you don't need to use the documentation as much. And so that's very helpful, but totally optional. You do not need to install Fig or use something like this in order to do the course, but it is a great tool if you want to use that. Now that we've got our tools, the next step is to download the code for the course. And we'll come over here and grab the SSH string. Then make sure that you're in the folder that you want to put this repo, and we run git clone, and then we'll paste in that. So the next step is to check out the correct commit for the lesson that we want to work on. So in order to do this, we'll grab the hash of the commit. If we run git log one line, first I have to go into our directory. And then if I run git log one line, we get a list of all of the commits in this branch. So we want to start at the beginning, so we'll copy this hash and then run git checkout-b, and we'll put in the branch name and then paste in the hash. And now we can see that we're on a branch where we're starting from the beginning. And so once you've done this, you're good to go to start on the next lesson. But before we end, I want to show you something quick so that you can experiment and play around with this Nuxt app as we go through the course. In my mind, experimenting and playing around with something is the best way to learn it. So I highly encourage you to do this in between lessons. Perhaps you go through the lesson on NuxtLink and that really interests you, and so you want to play around with it some more. Feel free to add in code and hack around on the project. Then when you want to come back and continue on from where you left off, you can just pull out the appropriate commit. So let me show you how to do that. We'll go back to our main branch. We'll run git log one line again. And so let's say that we went through navigating with NuxtLink, and then you started hacking away, and now the repo is kind of in a messy state and you don't know how to get it back to where we left off. That's totally fine. All you need to do is say, well, okay, I left off on 1.9, so then let me start over from that commit. Each of these commits includes what we went through in that lesson. So 1.9 includes the changes from that lesson. So if we wanted to continue with 1.10, we need to go to the one before it. So we'll grab that hash. We'll do the same thing as we did before. Now if we look at our git log, we'll see that we're on a branch that includes all of the changes from the different lessons up into 1.9. So now we're able to dive right back into the course, starting with lesson 1.10, and continue on our way. The last thing that we need to do is to actually install all of our dependencies. So with pnpm, we do that with pnpm install, but we need to make sure to add the shamefully hoist option. And once we've done that, we're good to go. Now we're able to start learning Nuxt 3. In this very first lesson, we're going to take a look at how we can use the file system to create the routes for our application. And we'll see how Nuxt automatically generates those routes from our file. First, we'll create the pages folder that all of our pages will live in. And then inside of that, we'll create an index.vue component, which will be our root page. And we'll just throw in something really simple so that we can get started. Then we'll start our dev server. And we'll refresh the page here. Great. The very first step, we've got something rendered to a page. Although it's not very interesting yet. But don't worry, we'll get there. If I make a change to this code and then save it, we'll see that Nuxt automatically reloads our page. This is called hot module reloading, or HMR for short. Anytime we make a change to one of the files in our app, Nuxt will automatically reload the dev server. However, if you make a change to the name of a file or add in new files or delete them, you'll sometimes have to restart the dev server entirely so that it will pick up those new files. This hot module reloading makes development really easy because we don't have to keep going back and restarting our server. We can see the changes we're making as we make them. Next, we'll create a page where we'll show the course itself. To view this page, we can go to /course. Nuxt automatically generated this /course route for us and then matches it to the course.vue component we just created. Nuxt will look at the file structure of our pages directory and then use that to automatically generate our app routes for us. A route matches the URL to a specific component in our app. If we open up the DevTools, we can see all of the routes in our app. Here we can see the index route that maps to the index.vue component that we created, as well as the /course route, which matches to the course.vue component. Nuxt uses Vue Router internally, and that's where all of these routes are coming from. Nuxt allows us full access to this Vue Router if we need more control, but we won't be going into that in this course. In most cases, we can rely on Nuxt's file-based routing system to generate what we need, and we don't need to worry too much about how Vue Router is being used under the hood. In every single Vue app, the component that starts it all is App.vue. Right now, we have a simplified one, and all it does is render our Nuxt page inside of a Nuxt layout component. This Nuxt page component is what renders the component that's matched based on the route that we are at.
So when we go to the /course route, the router matches that to the course.view component, which gets rendered through this Nuxt page component here. If we look at our components in the DevTools, we can see how this works. We have our Nuxt page, which renders the router view from view router. Then we have a transition component, another transition component, and then finally, it renders out the course component that we have created. So that's the basics of how file-based routing works in Nuxt. In the next lesson, we'll take a look at how we can use nested routes to create more complex hierarchies and more powerful web applications. But before we get there, we're going to flesh out our course page just a little bit. I have some code here that I'm just going to paste in. We're using Tailwind classes along with the Tailwind typography plugin just to get some nicer styling out of the box. So there we go. We've got the basics of our app fleshed out. Now we can move on to the next lesson. The most important feature for our app is displaying different lessons from our course. So in this video, we're going to figure out exactly how we want to do that. We want the route in our address bar here to be synced to our chapters and our lesson. By doing it this way, we can link straight into a specific lesson, which lets us bookmark the URLs and share it with others more easily. And in general, it's better when the route for our app is as descriptive as possible of the state of the app. Twitter is a great example of this. If I click in on a tweet, we can see that the URL shows exactly what that tweet is. It contains all of the information that we need to render this page. It tells us the user, and it tells us that we're looking at a status, and then it has the ID of that status, or in this case is actually a tweet. And if we click on a different tweet, we see that the status changes. And if I go back to my home page here, the route shows /home, because that's all that we need to know in order to render out this page. So in our app, what we want is something like this. Course /chapter / the name of the chapter / lesson / the name of the lesson. Now, this isn't the only way that we could do it. This is just the way that I've chosen. It's very descriptive. Just by looking at it, you can see what chapter we're on and what lesson we're on. Now that we figured out what we want our route to look like, now we need to figure out how to build that into our app. So what we want to happen is that our course page should display whichever lesson is indicated by the route. This means that this lesson here is actually nested within this larger page. Why don't I show you what I mean by that? If I change the background of this section here, the section with the lesson, when we switch between different lessons, all that we need to change is this red part here. Everything else in the app can stay the same. The header can stay the same. The list of chapters will stay the same. All that we need to change in between the different lessons is this red part here, the part that actually shows the lesson. We're going to accomplish this in 2 steps. over the next couple lessons. First, we'll separate out this lesson into its own page so that it will match the new route /course/lesson. Then we'll add in dynamic parts into our route so that we can access different chapters and different lessons and not just the same static route. So let's get started on that. We're going to add in the nested child route that will display our lessons. To do this, we'll create a lesson.vue page, but we'll nest it inside of a course folder. We can see that as soon as we save that, we get this new route in our DevTools here at /course/lesson, matching the file path of this new component. And we can see that in the UI here, it shows that it's actually nested underneath the course route. But to get this to actually work, we need to modify our course page now. We'll replace this with a Nuxt page component. If we go to /course, we see that nothing shows up here in this red area. That's because Nuxt matches the /course route to the /course component here. But because it doesn't have any more to the route, it finishes rendering, and nothing gets rendered into this Nuxt page area here. But if we go to /course/lesson to match the new component that we created, we see that this component that we just created shows up in this red area. Nuxt renders both the course.vue component as well as the lesson.vue component because we have two Nuxt page components. The first one is this Nuxt page in the App.vue at the top level. And then the second is inside the course page component right here. Remember, this Nuxt page component is rendering out the component that is matched by the router. So what Nuxt is doing is, from left to right on our route, it's going to try and match as much as it can. So when we go to /course, it gets an exact match, and so all it shows is the course page. But when we get /course/lesson, it matches first on the /course to render the course page. But because there's this Nuxt page nested in the course page, it keeps on going and can match to the /lesson now, rendering out the lesson page component in here. It's important to point out here that the only reason that this works is because we have this second Nuxt page component. If we don't have that component, then Nuxt can't match any further. So when we go to /course/lesson, nothing is rendered out here. Let me show you what this looks like in the component hierarchy. So at the very top here, we've got the app component, which renders out this Nuxt page. And that Nuxt page does a bunch of things, but renders out this course page, as we saw in the very first lesson of this course. But if we open up this course here, we see that this also renders a Nuxt page, the nested Nuxt page, which then renders, eventually, it renders our lesson component. So this is how nested pages and nested routes within Nuxt operate. Another way to think about it is like folders and files on your file system. Because this lesson page component is nested within this course folder, we must also match that to our code. And so this Nuxt page, which renders out the lesson component, is nested within this course page component. And that also matches the route that we use to access that, where this lesson is nested within the course route. So all of these things match and work together. Now that we have nested routes working within our app, we need to add in some dynamic sections to this route so that we can select different chapters and different lessons, because there's more than one lesson in this course. So let's do that next. Currently, we're only able to show one lesson. But that's a problem because no course that I know of has a single lesson. That would be a very short course, and you probably wouldn't be learning a lot from it. So in order to do this, we need to add dynamic sections to the route, where that part of the route then can be extracted as a variable that we can use in the logic of our app. Nuxt makes this really easy for us. We just need to add in square brackets into the file path name. And then that lets us define these route parameters. So let's define that route that we looked at a couple lessons ago. We've updated our file path to match that route that we wanted to have with course/chapter/ the name of the chapter /lesson/ the name of the lesson. And while we're here, I wanted to quickly show you a neat trick we can do with VS Code, where we can actually rename this directly without having to create all of these folders ourselves. So I'll just rename this directly, including the different directories that we want to use. Great. All of our folders are in the way that they should be. And now our folder structure mimics the way that we want our route to work. Now we just need to update this route that we're looking at in the browser. And perhaps restart our DevTools because we did a bunch of file system changes that weren't picked up by the hot module reloading. Perfect. There we go. So in order to use the chapter slug and lesson slug route parameters, we can use the global $route variable, which we can access from inside of any template in our app. We can see now that our lesson component is rendering out the chapter slug and the lesson slug. And if we change this to some other value, it'll update there. Now the next step for our app is to actually use these slugs to load in the right course data. But before we move on to that next lesson, I want to take some time to show you all of the different things we can do with dynamic routes in Nuxt. We can mix and match static and dynamic parts within each segment of our route. So here we only have two route segments. We have chapter hyphen the chapter slug, and then lesson hyphen the lesson slug. If we restart our dev server, and we go to a made-up route, once I put this in the course folder so that the route is correct, and then restart it again, there we go. So in our file system, we can see that we have course slash chapter hyphen chapter slug, lesson hyphen lesson slug. And that's exactly what we have here in our URL. We put chapter hyphen hello slash lesson hyphen there. So when we pull out the chapter slug and the lesson slug, that's exactly what we get. So we can mix and match static and dynamic within each segment. We can also combine multiple route parameters within the same segment. We just have to be careful about what characters will split them. So I'll update this here to have both slugs within the same route segment. So here our route in the file system is course slash the chapter slug hyphen the lesson slug. And once I've restarted the dev server and gone to this route here, chapter slug, lesson slug, we see that that's what's pulled out into our lesson. Now we need to be careful about what character we're using here to separate these two, because that character can't appear in this first slug. Because of the way that the regex works, it will get confused and it'll separate it in the wrong spot. So just something to keep in mind there. That's why we usually have one route parameter per segment, because we know the slash will separate the route segments. Now I've got one last thing that I want to show you before we move on. We can actually have optional segments using double square brackets. Now we've created a route that will match on both having just the chapter slug as well as having the chapter slug and the lesson slug. So here, if I go to /course/chapter slug, it pulls the chapter slug out as a route parameter. But since we haven't specified the second route parameter, it doesn't exist. But if we need to, we can go to /lesson slug, add that on the end, and we see that populate there. And in our dev tools, we can see how this is represented. We have our route parameter here with an optional route parameter with the question mark. Having a route like this doesn't actually make any sense for our application, so let me reset this quickly and then we can move on with our application. Now it's time to add in the course data that we'll actually be working with to show some lessons. So let's do that. See you in the next video. Our next step is to load in the actual lesson data. I've put together a file with our demo data already. It's actually the first part of the TypeScript course from Vue School. To use this data in our lesson component, we'll create a basic useCourse composable. A composable is a reusable piece of logic that uses Vue's reactivity system. It's a way for us to better organize our logic and reuse it across multiple components. Composables are always named use something. This makes it easy to see what is a regular method and what is a reactive composable. If it doesn't use refs, computed props, watchers, or any other Vue logic, it's just a regular JavaScript function. Those I would probably just call utilities. Instead of creating the file manually, we can get Nuxt to help us scaffold it with a template using the Nuxt CLI command. Nuxt will create the file, and since we don't have any other composables already, it will also create the composables directory for us. Using Nuxt, we can scaffold templates for composables, components, pages, layouts, plugins, middleware, and API routes as well. This tool comes with many other commands, including Nuxt upgrade, which makes it a breeze to update to the latest version of Nuxt. Now, let's make sure we can get this data into our lesson page. First, we'll move the course data into the composables folder. Now, let's import our course data into the useCourse composable, and then return it directly from the composable. Now, we'll add in a script setup section to our lesson page and get the course data from the useCourse composable, logging it to the console. Notice how we didn't even need to import this composable. That's because in Nuxt 3, we get auto imports. Most things are auto imported by default into our components. This includes components from the components folder, layouts from the layouts folder, and composables from the composables folder. Lots of additional libraries are also set up for auto imports, like Piña and VueUse. And you can configure this behavior and even add your own custom auto imports if you want. This is really convenient and greatly simplifies our code. And don't worry, Nuxt works hard to keep our apps fast, and it will only auto import the things we actually need in our app. Now we need to start up our dev server again, and we can see that this course data is logged to the console. Great. We can see everything is being logged to the console, and so we know that things are hooked up and the data is flowing. Now it's time to display the lessons. We need to use the chapter slug and lesson slug route parameters to find the right lesson and then display it. In our script, we can get the route using the useRoute composable that's built into Nuxt. We'll search for the chapter that has a slug matching the chapter slug route parameter. Then we'll do a similar thing to get the lesson, this time searching the chapter for the right lesson. Finally, we need to use this lesson that we've found in the template. When we refresh, our app crashes. The reason for this is that it's trying to look up chapters and lessons that don't exist. Instead, let's go to a lesson that does exist. And here we see that Nuxt is pulling the correct chapter and the correct lesson, and then rendering out the titles for each. Since the last lesson, I took some time to update the styling of our lesson page. I removed the red background since we no longer need it. I added in the lesson title along with the chapter and lesson number. You can see this change in the lesson slug page. I added in a section with external links so we can download the video for the lesson as well as the source code, if there are any. Finally, I also added in the text for each lesson. This is usually just a description of what the lesson is, so a single p tag here is fine. We can also see what it looks like with the second lesson. Now it's starting to look like something. But we're missing one very important piece, which is the video player. We'll add that to our app in the next lesson. We need some way to display our videos on the lesson page. Let's create a video player component to do that. We may want to add more features to this video player in the future, and embedding a video is already quite a few lines of code, and we don't want to clutter up our lesson page too much. As mentioned previously, any component added to this components folder will be auto-imported into any page or any other component that needs to use it. Of course, we don't have to rely on Nuxie to do this for us. We can also create these folders and files ourselves if we want. Let's update this component so we can embed our videos from Vimeo. First, let's define the template. This iframe is the embed code that's given to us by Vimeo in order to embed a video on our page. We'll also make the source prop dynamic here so we can pass in whatever video ID we want. Then we'll need to define the video ID prop. Now we can add in this video component to our page. Whoops, it looks like we forgot to actually escape our variable in this template in our video player component. But once we fix that, the video loads as it should, directly in our lesson page. And if we navigate back to the second lesson, we can see it loading that as well. Perfect. That's all we need to do in order to create and use components in Nuxt. Pretty simple. Now we can watch the videos in our course. But we can't easily navigate between the different lessons. Let's fix that next. Let's pause for a moment and take some time to understand how Nuxt is rendering our app. So in general, there are two main kinds of apps that are built: single page apps and server-side rendered apps. With a server-side rendered app, when you go to a web page, that request is sent to the server. The server does a bunch of processing to render out that page and then sends it back so that your browser can display it. And if you click on a link or interact with the page, the same thing happens. Makes a request to the server, some processing happens, and then the new page is returned. In a single page app, things work a little different. You make a request when you visit the page. The server does some processing, just a little bit, to send back the entire app as one big JavaScript bundle. Then, once that bundle is on your browser, it does a bunch of processing and then renders the page in your browser. But when you click on a link in a single page app, we don't send a request to the server. We just do some more processing and then render that next page. Now, single page apps do make requests to the server, but they're only fetching the raw data. They're not fetching the HTML and CSS that will be rendered in the browser. The main differences between these two approaches are that with a single page app, the initial page load is quite slow because you have to load that entire huge app bundle. But a server-side rendered app is very fast to start up because you're sending over only a small amount of data. A single page app is quite fast on every subsequent click though, because there are no round trips to the server. Everything is done in the browser. We're not waiting for the server to process our request and then send it back. And that's exactly the downside of a server-side rendered app. So you can see that each of these has a really good strength. And what Nuxt does is combines the best of both. Universal rendering, we get very fast startups and then minimize the round trips to the server after that initial startup time. When you go to a web page, that request is sent to the server. Some processing happens to render out that initial page, just like with server-side rendering. And that rendered page is sent back to your browser to be displayed on your screen. But while you're browsing around on this page, maybe deciding what link you want to click on next, it also sends over the app bundle, just like with single page apps. So when you click on that next link or interact with the app in some way, just like with a single page app, no request is sent back to the server because we have the app in the browser already. So the app does some processing and then we get our next page. Now, all of this means that universal rendering is extremely fast, both on the initial page visit and on subsequent page visits. I am simplifying things a bit though, because Nuxt actually has a bunch of other optimizations that it's doing to make things even faster. For example, with NuxtLink, the different links that are in the page will be prefetched as you're scrolling through the app to try and get all of that data to your browser before you even need it. And that's just one of many different optimizations that are going on under the hood that you don't even need to worry about. So now that we understand how Nuxt is rendering our app, and we have a deeper understanding of what's going on, it's time to get back into coding our app. Let's add in all of the chapters and lessons to the navigation now. First, we'll grab all the course data using our useCourse composable. Then, we'll render out each chapter in our navigation. Nice. Now we can see all 3 chapters rendered out into the navigation. Next, we'll add in all of the lessons for each chapter. Awesome. Now we can see our lessons also rendered underneath each chapter. We'll also add a max width to our navigation so it's not so wide. Since we're so far zoomed in this case, it doesn't really show up as much, but it does make a difference. Great. Now we have the navigation rendering, but we need to make those links actually go somewhere. We can use the chapter and lesson slugs to construct the correct paths for each lesson. Now, if we click on the links, we go to each lesson. You'll notice that as we click around, it's fast, but not instantaneous. This is because we're hitting the server for every single page that we go to. We're not taking advantage of Nuxt's universal rendering. To do this, we need to use the built-in NuxtLink component. NuxtLink is a drop-in replacement for your regular A tag, but you need to swap the href attribute for the to prop. Now, if we click around through the lessons, you can see that each new page loads instantly. Of course, the video takes a bit longer to load, but there's nothing we can really do about that. This is a pretty dramatic speedup. I mentioned before that Nuxt uses ViewRouter internally for all of its routing, and that's the same here. The NuxtLink component wraps the RouterLink component from ViewRouter, but gives us some extra magic on top. It lets us navigate entirely on the client side without ever hitting the server again. This makes it extremely fast. NuxtLink will also prefetch pages when the link is in the viewport. So before you even click on the link, the data for that page is already being loaded in the background. You could say that NuxtLink is one of the secret weapons that Nuxt uses in order to be incredibly fast. In the next lesson, we'll look at more of what NuxtLink can do for us. I want to point out an error that I made in a previous video where we added in the VideoPlayer component. This prop of video ID is set to a string, but it should actually be a number. So we're just going to change that quickly right now. So the NuxtLink component isn't just for internal links, it also works for external links. With external links, the NuxtLink component doesn't wrap router link from view router, but we're still getting some magic. By default, it will add the no refer and no opener values to help keep our links secure. Now, let's take the path that we're computing in the template and instead pre-compute it and add it directly on to the lesson data itself. This is helpful because it moves logic out of the template, and the route or path for each lesson is something we'll likely need later on, so it's nice to have it already on the object. First, we'll need to modify each lesson of each chapter of the course. We can do this using maps. So far, this does nothing other than deeply clone the entire course data object. To add on a new path property to each lesson, we'll copy this template that we already have here. And we'll paste it into the lesson object in useCourse. Now we can replace that template with lesson.path. And clicking around, we can see that our app still works. Great. The navigation right now is good, but it doesn't give the user any context for where they are in the list of lessons. It's a small thing, but it would be nice to show a bit more. So let's highlight the lesson we're currently on with a different text color. To do this, we'll use the router link active class. This is a feature from ViewRouter that lets us style the currently active link. Once we refresh the page, we can see that our current lesson that we're on is highlighted in blue. Using @apply lets us add a Tailwind utility class to another CSS class, and it comes in handy here. And since we're using Tailwind in this project, there's actually another way that I prefer. We can use dynamic classes on our NuxtLink and check our lesson path against the current route in order to determine which NuxtLink is the active one. Once we refresh, we can see that this method works as well. I like this method of styling the active link better because it keeps all of the styling for this navigation section together. Co-locating similar code in one spot makes it much easier to understand and update in the future. If we used the other method, we'd have to hunt around a bit more in order to find where to change the styling for the active links. Of course, our project is quite small right now, so it's not a big deal. But this does make a significant difference on larger production-ready applications. Most of your time ends up being reading and understanding the code, with a small part actually modifying the code. So if you can make your code easier to read and easier to understand, you'll get a lot of benefits from that. We have one last thing to do before we finish with our navigation. Right now, we aren't updating the title of our web page whenever we go to a new lesson. So that's something that we want to change. Instead of having the URL up here in the title, we want to have the lesson displayed. And whenever we switch between different lessons, we want that to update in the title of the page. To do that, we'll use the built-in useHead composable. This composable lets us reactively modify the head of our page. We can update the page title, add in meta tags for SEO, and add in script or style tags, and basically anything else that you could do inside of the head tag on a normal web page. And we can do that all reactively through the useHead composable. But for right now, we're just going to update the title of our page. And we'll do that within the lesson page here, because we're already calculating the chapter and the lesson. And so we have easy access to those title values. But first, let's quickly see how this useHead composable works to update the title. We pass in a meta object as the parameter and set title to whatever we want. And as we can see in our app, it updates the title of the page to that string. But unfortunately, this static string is not quite what we want. Every property that we pass in here to the meta object for useHead can be reactive. So let's create a computed property that will calculate our new title. Now we can see in our app that the title of the page is updating dynamically based on the title of the lesson. And if we click around to different lessons, we can see that it updates as well. In the next lesson, we'll take a look at how we can use state management to track our progress throughout this course. It would be great if we could track our progress through the course and see which lessons we've completed and how far along we've come. For now, we'll just put a checkbox on this lesson page, but later on in this course, we're going to look at how we can integrate this with a backend that will connect to a database, and in that way we can persist that state, and we can see how our students are doing. To get started, we'll add in a lesson complete button, which I'll paste in here. Then we'll add this lesson complete button to our lesson page. Great, we can see that our button is now rendering to the page. But unfortunately, when we click it, nothing happens. We need to create a ref to actually track the state of this button. Now we can mark the lessons as complete. But we have a few issues here. When we go between different lessons, we see that we lose our state. This is because when we go to a new lesson, the lesson page is destroyed and recreated. This destroys the ref that we have tracking the state and then recreates it again. Another problem is that we're storing our state as a single variable. We end up with a collection of different variables, one for each lesson. This makes it really difficult for us to calculate the progress or save it in a database in a nice and clean way. It would be much better if we could store them all into one single variable. Instead, we can store all of these progress variables inside of an array. If we have an array for the entire course, then an array for each chapter, and then each Boolean variable within that represents whether the lesson is completed or not. This array is much easier to store in a database and also much easier to do computations on to track how far we've come in a specific chapter and also how far we've come in the overall course. We'll store this variable using the useState composable that's provided by Nuxt. You can see here that useState returns a ref to us. But unlike the ref function built into Vue, it works better in two important ways. Number one, we can share this state between different components so that each lesson can share the same progress state that doesn't get destroyed when we switch between lessons. And we're able to do this in a simpler way that doesn't require us to use Pina or Vuex or any other state management library that you may like. Number two, useState handles server-side data better than ref does. Right now, we're not really concerned about server-side state since we're only dealing with the client side. So we'll cover this more in a later lesson. So we'll switch over to using the useState composable. We need to give it a unique key so that it knows which piece of state we're trying to grab. And then also a function that will return the default value in case this value has not been initialized yet. Next, we'll use a computed value to grab the state that we're looking for from our progress state. Here we have a couple of guards before we actually grab the correct value. Because we're initializing our progress value to an empty array, we first need to check if there's an array for the chapter. If that chapter does not exist, then we know we haven't completed the lesson, so we return false. Then we check to see if the lesson exists. If not, we know we haven't completed the lesson, so we return false. And lastly, we know that the value exists, so we simply return the value. Next, we need a way of updating this progress state. Here we have a similar guard. First, we check to see if that chapter exists, and if the chapter array does not, we create it. And then, once we've made sure that the chapter array exists, we set the value, toggling it so that we can flip between true and false. The last thing to do to make this all work is to update how we're setting the value and updating it on our lesson complete button. Because we have a more complicated way of retrieving the value and then updating it, we can no longer use vmodel. Now when we go over to our app and we toggle this button, we'll see that it holds its state when we go between different lessons. If we open up the dev tools, we can also see how this is working in the progress state. Here we have our array of arrays to track our progress. Since we've only clicked on the one for lesson 3, this is the only one that's been set. If we go to lesson 2 and mark this as complete, then go to lesson 1, mark that one as complete, we can go back in here and see that the progress array has been updated. And if we toggle this button here, we can see that the value in our progress array also toggles. So to quickly recap, the useState composable that we've used in this lesson lets us create global state that we can use across components so that when these components are created and destroyed, or even if they're in memory the whole time we're using the app, we can share the state across all of these components. But we have one problem. If I refresh this page, we lose all of our state. That's because we're not persisting this state anywhere. That's what we'll cover in the next lesson. In our last lesson, we added in the lesson complete button, but then we uncovered a problem. By using the useState, we only keep the state around until we refresh the page. Now, obviously, this isn't going to work for our app. We want to be able to keep the state around much longer than that. So in this lesson, we'll look at how we can use the ViewUse module for Nuxt and sync our state to local storage. So that way our state sticks around in the browser as long as we need it. We'll worry about syncing all of this state to a database in a future lesson. ViewUse is an amazing project that comes with a whole host of composables. It also comes with a wonderful integration with Nuxt. And to install this, we need to install the module. I'm using pnpm, so I will use that to install, but use whatever tool that you are using for managing packages. We need to install the ViewUse Nuxt package as well as the ViewUse core package. Then, in order to use this module with our Nuxt app, we need to add it into our configuration. Now we're able to use the Tailwind module and the ViewUse module. And time to start up our server again. Swapping out useState for use local storage is actually very simple. This is all we need to do in order to get our app to use local storage. The ViewUse Nuxt module comes with auto imports built in. So all of the composables that you can use with ViewUse will be automatically imported, just like any other composable or component in your Nuxt app. So now let's check to see that our app is actually syncing the state to local storage. We can do that by going over to the Application tab in our DevTools, going into local storage, and clicking on localhost. We can see that our progress state is already in here. And if we click around to toggle the state, this will update. And that's it. Our progress state is now synced to local storage. And if I refresh the page, we still have our state. But you maybe notice this weird jankiness. If I mark it as complete, it shows as true in the local storage here. But when I refresh the page, it first flashes as false. You see the mark as complete show up. And then now it's showing completed, but the background of this button is not green, it's gray. But it still shows true here. Now, what's going on? This is a little bit weird. This issue is because of hydration. Remember, when we first go to a Nuxt app, it first uses server-side rendering to serve up the app, and then loads in the app to run on the client side. Hydration is the process of going from a static HTML page served up by the server to a fully interactive JavaScript application. If you've initialized state on the server, and then you want to load that state in the client, sometimes there are some interesting things that happen. So we need to pay a little bit more attention to how our state gets hydrated. In our app, we always initialize this progress state as an empty array. So every single time we refresh the page, it's an empty array. But then when the state is loaded on the client, it loads in the state from local storage. It does not use this default value anymore. And this causes a mismatch between the state that's on the server, which is an empty array, and the state that's on the client. So when we have a lesson that's completed on the client side, the server still thinks it's not completed. And so when we refresh, there's that weird mismatch. In the last lesson, we talked about useState, and now it has two benefits. Number one, that we can share data across multiple components. And number two, that it's better suited for server-side state compared to the built-in ref function. And this is one of the reasons why. Since we're not actually storing this state in the database on the back end, and we're just storing it on the client, we're not going to deal with solving it on the server. We're going to deal with it in a different way. Nuxt gives us a way to only render components on the client side, so that are not rendered on the server at all, using this client-only component. And since our state is only client-side right now, it makes sense to only render this checkbox button on the client side. Now when we refresh our page, we see that we don't get any of that jankiness. This is because the lesson complete button is only rendered on the client. It doesn't receive the incorrect state from the server. One of the downsides of using this client-only component is that we're not taking advantage of the performance benefits that server-side rendering give us. But because this is such a small part of the page, we don't really suffer any performance here. One last thing to keep in mind with this client-only component is that you should only use it when you have a component that sometimes is rendered on the server, but sometimes you don't want it to be rendered on the server. If, like we're doing here, you want this component to always be rendered client only, we actually have a better way of doing that in Nuxt. If we add the .client suffix to our component, then Nuxt will automatically render that component client only. We also have the added benefit that it's much more readable this way. Simply by looking at the file name, we can see this component is only meant to be rendered on the client. Before, we would have had no idea, and we could have incorrectly used that component in a way where it was rendered on the server. So just one thing to keep in mind. And because we renamed it, we'll have to restart our dev server in order for Nuxt to pick up that change. And as we can see, that jankiness is still gone because the lesson complete button is now client only, no matter where we use it in our app. So now we've got a pretty decent app going. It's got some pretty good functionality. We can look at different lessons. We can mark them as complete. That state is saved for us on the client. So the next step for us in our next lesson is to deploy that app using Netlify so that we can share it with our friends. We can use it as if it were a real app. Now that we have a decent app, let's deploy it. This way we can share it with our friends, we can share it with coworkers, and we can put it out there for anyone to access. This is one of the best parts about developing an app, is seeing it out there in the wild. We'll be using Netlify to deploy our application, but first, we'll need to set up the GitHub repo for it. To do this, we'll create a new repository and give it a name that can be anything you want. I'm just going to use mastering Nuxt here. It doesn't really matter if you set your repository to be public or private, but I'm going to choose private for now. Now all we need to do is copy these commands to push our existing repo to this GitHub repo. But we can also come over here and copy and paste in those commands. If we refresh our repo on GitHub, we'll see that our code has been pushed and it's inside of GitHub now. Now we'll need to go to Netlify and set up our account to deploy from this GitHub repo. We can log in using our GitHub credentials. We'll ignore all these failed builds for my blog. A little embarrassing, but we'll hit Add New Site and import an existing project. We'll click on GitHub. And I've already authorized Netlify to interact with my GitHub account, but you may need to authorize it in that step. Now we need to configure our Netlify app to be able to see and interact with our specific repo that we just set up. You can choose to have Netlify be able to access any repository in your GitHub account, but I prefer to keep it locked down. It just keeps things a little cleaner and prevents any weirdness from happening in the future. So we'll select our repository that we just created. And hit save. Now we can see our Mastering Nuxt 3 repo in this list. If we select that, we'll be able to import that from GitHub. Nuxt will automatically detect that it's being built on Netlify and will configure itself to work with Netlify. We don't have to do much at all here. We just need to hit the Deploy Site button. Let's go to our Deploys tab on Netlify to see how it's being deployed. We can see the log from Nuxt as it builds our app. Bundles it up, and then deploys it to Netlify. Now that it's deployed, we can go check out the live site. We refresh the page. Now we can finally check out our deployed site. We can see the homepage, which just says Hello World, but we can also navigate to one of the lessons. And here's our app working in all of its glory. Unfortunately, these videos are restricted because we only want them to be able to be seen on the local host. Otherwise, we would be giving them away for free. But other than that, this app works exactly as it did on our local machine. Now we can share this app with our friends, with our coworkers, whoever might be interested in checking this out. You can even tweet it out and share this with everyone. But don't forget to tag Mastering Nuxt in your tweet if you do. Now we need to see how we can trigger a new build. If we go back to our Deploys tab, we can see that there's a drop-down here for triggering a deploy. This lets us manually deploy the site if we need to. We can also set up Netlify to deploy a new build whenever we push a new commit to our GitHub repo. This is great because it lets us see our changes as we're developing. We don't have to manually trigger this build. It just will automatically build as we're working. To do this, we'll go to our site settings. And we'll go down to build and deploy. In the branches setting here, we'll edit this to all so that any branch that we push will be automatically built. So if we're working on a new feature, that branch will also be built so we can test it live. We can get feedback from others before we push it into the main branch. For example, if we wanted to update the styling in our app, we could create a new branch for that and work on that there. We can quickly update the styling on the course page. Let's change it to blue. We'll create a new commit. And then we'll push that commit to this new branch that we've created. Let's go back to our Deploys tab and see what Netlify is doing. We can see that Netlify has automatically created a new branch deploy from our update styling branch. Once that's finished deploying, we'll be able to check how this code looks live. Our new branch is now deployed, so let's go check it out. And we can see the blue background live on our branch deploy. At any point during the rest of this course, you can deploy your app just by pushing to the main branch or by creating another branch if you want to tinker around and try out some stuff. And I highly encourage you to do that because playing around with things and experimenting is one of the best ways to learn anything. And by deploying and seeing what it looks like as a live site, you can get more feedback. And once you're done experimenting, you can finish up and deploy the site, and Netlify will build it and publish it for you. And don't worry about getting off track when you are experimenting and playing around with different things in Nuxt. If your code is too far gone, you can always resync to the beginning of the next episode. Each lesson has a commit, and you can resync back up to that state. So go have fun and enjoy playing around with Nuxt and learning everything about it.
So we've built ourselves a pretty decent app with Nuxt, and we've deployed it to be live for anyone to access. We took a look at file-based routing and how we can use dynamic routes and nest child routes within each other. We took a look at NuxtLink and how using that allows us to take more advantage of the performance benefits and optimizations that Nuxt gives us. We also looked at useState for managing our state, and we looked at how we can use ViewUse Nuxt module to help us add some extra functionality to our application. Now that we've seen the basics of how Nuxt works, it's time to take a step back and look at the architectural side of things. We want to make sure that our code is organized well so that we can develop our Nuxt applications well over the long term. Maintainability in a large production quality app is one of the top concerns, because once you get it launched and once you get that first version out, you still gotta ship more versions after that. So in this chapter, we will look at how we can use pages, layouts, components, and composables to better organize our code. And we'll see when we might want to use one over the other and how we can deal with organizing our code over time as we're developing our app out.
So we've built ourselves a nice little app, but it's not enough to get it to work. We also want it to work well. And a huge part of that is making sure that our code is readable and understandable for all of the devs coming after us or ourselves in the future. And generally, in software development, smaller is better. Smaller pieces are easier to understand, they're easier to manage, because big pieces of code are hard to wrap your head around. They're hard to fit all of the code and all of what it's doing inside of your head at one time. Now, the one caveat is that we also don't want our code to become too small. We don't want these pieces to become so tiny that they become tedious and frustrating to manage. We don't want to have so many of them that we're constantly jumping between files and always trying to track down where that piece of functionality is. So in order to do this, we want to split up our code into manageable pieces that we can organize much more effectively. Nuxt gives us a few tools in order to help us do this. We have components, we have layouts, which we'll get to later on in this chapter. We have pages, and we also have composables. Now, we've already seen how to use pages with Nuxt. We've got our course page, we've got our index page, we've also got this page for our lesson. In theory, we could have stuck all of this code from the lesson page into the course page. Functionally, that would have worked, but it would have been cumbersome and harder to deal with, especially over time as our app grows in size and complexity. We've also seen how we can use components like this lesson complete button and our video player component, and how we can take pieces of functionality and break them out into smaller chunks that are more suited for organization and for reusability. We've also seen a bit about using composables to share logic across our app in different places. In a few lessons, we'll look at how we can take layouts to extract code that's common across multiple pages and how we can use that along with some extra magic that Nuxt gives us to better organize our application. We'll also take a look at the differences between all of these methods, pages, layouts, and components, and see when we might want to use each one and how you can decide where to put your code. But before we dive into those lessons, let's first take a deeper look at our App.vue component. Every single Vue app starts with the App.vue component. This is the root component of your application, and it's what loads in everything else. All of the other components, the styles, everything else starts with this component. We can see in our dev tools here that this is the root of the app, with the exception of this Nuxt root component. The App.vue component that we have here is a pretty basic one. It's the default one that you get when you first start a Nuxt app. This Nuxt layout component will render the current layout to the page, Using this component, we can dynamically set the layout in a whole multitude of ways, which we'll see later on. This Nuxt page component we've seen before. It's what renders out the current route page to the page. This component is necessary if we want to use the pages directory in order to define the routes for our app. Most websites will end up using pages like this. However, you can set up your App.vue component to render whatever components you want in whatever way you want. And before we wrap up this short lesson, I should point out that both the Nuxt layout and the Nuxt page components cannot be the root of the component. That's why we have this div tag wrapping it all. Now, on to understanding how layouts work and can help us to organize our code better. In this lesson, we're going to take a look at layouts and see how they can help us to organize our code within our Nuxt application. Most web applications share common code across different pages. So I've got Amazon up here, and you can see that this is a product page. I've also got a today's deals page open. Now, the main content on these pages is completely different. One is showing a single product, trying to get me to buy it. And the other is showing all of these different things that I might be interested in, trying to get me to explore and to search through new products. But you'll notice as I switch between that this header at the top is actually the exact same between the two pages. They share this functionality in common. And if I scroll to the bottom, you'll see that this footer is also the same between the two pages. What layouts do is they allow us to share common code like this across these pages. Instead of defining the footer and the header multiple times in different pages, we can define it once in a single layout and then use that layout in multiple pages. They also give us a performance benefit because we're not shipping extra code or mounting and remounting the same elements over and over again as we switch between different pages. Before I show you how to use layouts within Nuxt, I want to quickly get something out of the way. You may be wondering, well, why can't we just use components like we have been? This is exactly what components are for. They let us pull out common pieces of functionality that we can reuse in multiple places. The first reason is convention. All Nuxt apps are built in the same way. And so if you use layouts for this type of code, then any developer who's familiar with how Nuxt apps work know that if they want to change something on the footer or they want to change something on the header, that code is likely to be found in a layout somewhere. So that's the first one, convention. It helps us to make our apps easier to understand and to navigate. The second one is that Nuxt actually adds a whole bunch of extra magic onto layouts, which we'll get to in a moment. Things like dynamically updating, transitions between layouts, deep integrations with Nuxt content if you're using that in your web application. But now let's create a default layout for our app. We see in our course component that we've got a bit of styling for the background. But in our home page, it's pretty basic. Let's add a default layout so that both of these pages use the same background styling. To create our default layout, we'll just create a default Vue component in the Layouts folder. Then we'll add in our template. And then remove this extra div from our course page. We can see that our course page looks exactly the same. So that works. But now let's go to our home page. Now, because it's using the layout, it has the gray background and centers the text on the screen. As we saw in the previous lesson, our App.vue component is rendering out this layout and then rendering out the home page within it. So that's how we're able to get this default styling here. We're able to do much more with layouts than just to provide some default styling across pages. We can use the define page meta composable to dynamically change what layout we're using on a page-by-page basis. If we set it to false, it simply won't render a layout at all. So when I save and refresh this page, suddenly we've lost our layout. We can also specify custom layouts. So let me first create a new layout. And we'll add in a blue background for this one. In our course page, we change this to the name of the layout that we want to use. And we can see that now we've got that blue background. Kind of snazzy. The value we use for this layout doesn't need to be static. We can use a reactive variable here, and the layout will update as that value changes. But we don't need to use this composable at all. We can hard code the name of a specific layout onto our Nuxt layout component. Now, both our course page and our index page, our home page, will use the same blue background. So that's how we can use layouts in Nuxt to organize our code. Right now, our app isn't too complex, so we don't actually need more than one single default layout. But as the complexity and the size of your app grows, you'll need to find more and more ways to organize your code better, and layouts become extremely valuable. So let's quickly reset our app before we head on to the next lesson. So we have a bit of a problem here. We've got 3 different ways to render content with our app. 3 places to put code in our Nuxt app. We've got pages, we've got layouts, and we've got components. But how do we know when to use each one? That's what we'll be exploring in this lesson. So the main challenge between all of these options is that at the end of the day, they're all components. A course page here is a Vue component. A layout is a Vue component. And obviously a component here is also a Vue component. So how do you decide between these different types of components? Well, the key thing I want you to focus on is the special properties that Nuxt gives to these different types of components. We've seen that with pages, they're used to define routing. Layouts are given some other special properties in being able to share code more easily between different pages. And the nice thing about components is that they are lightweight and they don't have any extra magic or fluff on top of them. So here's how I like to think about this. By default, I like to put my code into pages. Just get it to work. And as it becomes more and more complex and cumbersome, then I'll start to worry about moving that code to other places. But in the beginning, just worry about getting this stuff to work and put your code into a page. That's fine. Then as you start to develop your application and you start to see more and more pieces are common across these different pages, then you can start to pull out these commonalities into different layouts. And then if you have any other smaller independent pieces of functionality, you can put those into components. So let's take a little deeper look at each of these steps. And really, they're not steps that you might follow in a linear way, but you might jump around in here. So you'll see what I mean in a moment. So with this, we just want to get things to work. That's always the goal initially. Get things to work and then get it to work well. And then as you develop, you will find that there are commonalities across these different pages. You might notice that there are the same header or the same footer, like with the Amazon example that we showed previously. And you might notice other things, similar styling, similar layout code. And so you start to pull things out into different layouts. One thing I like to keep in mind here is the rule of 3. And that states that you want to see something happen about 3 times before you create this abstraction for it. If it only happens once, or even 2 times, it might not be worth pulling out into its own layout. But once you've seen it happen 3 times, you know, well, this is probably something that I want to have in a layout or in a separate component. Once you've hit 3 times, you know there's a pretty good chance that you will want to reuse that piece of code even more times. You also want to make sure that when you are building out this layout, that there might be some minor variances between how one page uses the header and how another page uses the header. And once you have 2 or 3 examples, you're better able to know how to write that layout code. So that's just something to keep in mind. Now, of course, when you're looking at the design and maybe you've got a mock-up from your UI designer, you can see that some pieces are going to be repeated across these different pages. And so you don't always need to wait until there are common code across these different pages. You can start from the beginning writing these out as layouts, but you don't have to. You can always refactor and clean up your code as you go, as you see that you need it. Now, as you keep developing your app, you might find that there are self-contained, independent pieces of functionality that you can move from a page or from a template into a component. So perhaps you've written a layout that contains a header that's shared across multiple pages. Well, you can start to build more layouts that also use a similar kind of header. Well, now it makes sense to go one step further and pull out that header into its own component. And then these templates can all use that component. Before I get into showing some examples, I want to take some time to go through a couple points you want to keep in mind as you go through this process. Sometimes deciding between whether something should be a layout or go straight to a component might be tricky. So one question I would ask is, where would you expect to find that code? We created a video component, and to me that seems like something that when I'm going through the code base, I would expect that a video player would be its own component and not part of a layout. Whereas a header or a footer, I would expect that code to be part of the layout and not necessarily its own component. Another way to think about this is that components typically do one thing, whereas layouts often do multiple things. So a component would play a video or provide us a button to mark a lesson as complete. But a layout would combine a header with a footer, some styling, as well as the Nuxt page that we are going to render. So that's another way of thinking about it. But in general, this idea of incremental refactoring always applies in that start by putting code into a layout, and then if you find that it makes more sense to move it into a component, you can always come back and refactor and move that into a component later on. And once we start dealing with abstractions like this, there are no hard and fast rules, and a lot of it relies on intuition and experience, and it's something that's frankly very difficult to teach through a course, unfortunately. We've been following this method of development throughout this course. I've been trying to keep it as close to how I would actually develop a real production app. We started writing everything in this course page component, and we had all of the lesson rendering in this component as well. But then we eventually factored that out into its own component. And then we created this lesson slug page component. So we started by just getting things to work, and then eventually we started to split things out into different page components, and then into a layout component. We started out by developing our app as one page component. But then as we went, as the complexity grew, it made sense to pull some of that logic and some of that markup out of the course page and create this lesson slug page. We also pulled a bunch of the styling from this course page component and moved it into this default layout component. We wanted the styling to not just apply to the course page, but to the home page as well. We've also created some components. We created this video player component from the start as its own component because we knew that it made more sense to have this as a separate piece of functionality. The same thing with this lesson complete button. It's got a bunch of markup and a bit of styling, And because we want it to only ever render on the client, it actually makes more sense to have it as its own component. So these are just a few examples of how we've already been using this method to organize our code as we go. We're refactoring incrementally, not all at once, but as we see that we need it. And I want to reiterate that knowing where to place different things and how to organize your code and split up components and split up layouts and composables even, that all comes with experience. There are not a whole lot of hard and fast rules about how to do it. But hopefully these guidelines that I've outlined in this lesson can get you started and help you to understand when you might want to use a page versus a layout versus a component. We've gone through how to organize our code in our Nuxt app using pages, layouts, and components. But we haven't yet talked about how we can use composables to organize our reactive logic. First, let's give a quick definition of what a composable is. It's any reactive logic that we have in our app can become a composable. But first, let's back up and discuss a bit about what a composable actually is. Any reactive logic in your app can become a composable if it uses any of Vue's reactivity API, such as refs, computed, watchers, things like that. We can take that logic and package it up into a composable. And there are three main types of composables. We have single-use composables, where we're just trying to extract a bunch of complicated logic out of a page or out of a component so that it's easier to read. Again, smaller pieces are generally easier to understand and wrap our heads around. So all we're doing here is taking a big thing and breaking it into smaller chunks. We also have reusable composables. These are the most common type of composables, like our use course composable that we've created in this app, where we have a set of functionality that we want to use in multiple places. So we can just define it once in a composable and then use that composable all over the place. The third type of composable is generic. These are composables that are not specific to your business logic, but generally useful. Things like use local storage that we've used from Vue use. Any app could use local storage. And so this is more of a generic composable that's not specific to our own project. Almost everything you would find in Vue use, I would classify as a generic composable. But on occasion, you may find that you need to create your own generic composable to simplify your own app. When using composables, they all live inside of this composables folder. And any composable that we define here, whether it's a JavaScript one or a TypeScript one, if we have them inside of this composables folder, it will be auto-imported into our components and our pages and layouts. So we've already seen this, that we have this use course composable, but then in our course page, we don't have to import it at all. We just get to use it.
Now we've seen a few different ways in which we can use the features that Nuxt comes with to better organize and better architect our applications. We saw that smaller pieces of functionality are typically easier to understand and easier to organize. And we saw how we can use pages and layouts and components and utilize their different strengths to organize our code in different ways. A key part of production quality apps is making sure that they are robust and that they won't fall over when we put them out in the real world. In this chapter, we'll take a look at how we can make our apps more robust using TypeScript and adding in error handling on the client side and on the server side, as well as adding in custom error pages for 404s when pages are not found, as well as generic custom error pages.
Because Nuxt 3 is built from the ground up using TypeScript, it has deep integration with it, and it makes for a fantastic developer experience. Not only do we get type-safe code, but we also get some little features that improve the developer experience, like IntelliSense autocompletion. In this lesson, we're going to take a look at how we can use TypeScript in our Nuxt app. And if you're not familiar with TypeScript, don't worry. We're not going to use it too much, just enough to give you a taste of what can be done. We'll be adding our types in to our use course composable. To start, we'll add in a type for our lesson. TypeScript types have a slightly different syntax than a JavaScript object, but it is pretty similar. If we look at the data that we have in our course data JSON file, we can see that each lesson has a title, a slug, a number, a URL, a video ID, and some text. We'll need to add these in as fields in our lesson type. However, if we look at some of the other lessons, we'll see that a few of them actually have a source URL as well. This is because some of the lessons have code associated with them that you can download, whereas others don't. So we need to make this one an optional field. We can do that by adding in this question mark. Now that we've created our lesson type, we need to associate it with the use course composable. In order to do this, we'll have to refactor our composable just a little. Here we've created the lessons variable and assigned the type of a lesson array to it. So now TypeScript knows that this lessons variable is an array of the lesson type. And if we hover over the use course field here, we can see that TypeScript is picking up the type that is returned from this composable. Now we just need to add in the rest of the types. Now when we hover over this use course composable, we'll see that it simply returns a course type. And we know that this course type has a title and some chapters, and that this chapters is an array of the chapter type. So now our Nuxt app is typed with this course data. If we go into our lesson slug component, we can see that we now get much more valuable IntelliSense. If we come over here to our lesson, we can now see that our IntelliSense fills with the correct types because it knows that this lesson is of type lesson. This becomes very helpful and lets us understand the values that are being passed around in our application much more easily. As your application grows, it can be difficult to know where the data you're working with has come from and what the shape of that object is. But if that's typed properly using TypeScript, you can get VS Code or whatever IDE you're using to give you useful hints like this. Later on, when we build out our API, we'll see how Nuxt takes the types of those endpoints and automatically builds them and injects them into our client-side code so that when we fetch on the client side, we get access to those types. But TypeScript is just one way that we can add more robustness to our code. In addition to helping us give hints when we're coding, TypeScript prevents all sorts of small, annoying, tedious little errors from popping up. But we also want to add error handling and handle cases where the application doesn't work as we expect. That's what we'll tackle in the next lesson. In this lesson, we'll see how we can add in a custom 404 page to our app. If we go to some sort of random route, one that doesn't exist on our app, we get this big 404 error. But this is the default 404 page that Nuxt gives us. We want to be able to add in our own so that we can control how it works and how it looks so that it fits in with the rest of our site. Maybe add in a fun GIF or whatever it is that we want to do with it. To do that, we need to add in a 404 page in our pages folder. Now we get this page that uses our default layout and has some custom text in here. It's pretty straightforward. From here, we can add in whatever other functionality we want. We can add a button to redirect to a new page or add in a menu of some kind. In the next lesson, we'll see exactly how we can do that. So, how does this work? If we take a look at our dev tools and we look at the routes that we have, we'll see that Vue Router has a catch-all 404 route. And what Nuxt does is it matches this 404 catch-all route to the 404 page. If we don't provide one, it throws up that default one that we saw earlier. But if we have the page there, it'll show that instead. This catch-all route is only triggered if none of these other routes are matched. That's why it's called a catch-all, because if everything else fails, at least we have this route as a backup. In our next lesson, we'll take a look at how we can handle errors on the client side. In our Nuxt apps, there are two main sources for errors during the rendering process. The first one is on the client side, and the second one is on the server side. First, we'll tackle the client-side errors in this lesson and the next lesson. And then in the last two lessons in this chapter, we will tackle handling server-side errors. However, first I noticed that I missed something when we added types. So let's go in and add that type that I missed. We'll go into our use course composable here. And if I come down to where we actually have the composable, we'll see that we added this path in. And when we were adding types back in that lesson, I was so focused on the source data that I totally forgot about this field. So let's add that in right now before we forget. And that's all we needed to do. So now we can move on with client-side error handling. Nuxt 3 comes with this really useful Nuxt error boundary component. And what it does is it will capture any errors that happen in its default slot. This gives us a chance to show an error message and handle that error in a more specific way. So we can use these Nuxt error boundaries to actually isolate errors in different parts of our app instead of having a generic error page and just a generic way of handling these errors. So in our app, we're going to create an error when we click on this lesson complete button. We will use the create error method that Nuxt gives us. This method works on the client side as well as the server side, and it does exactly what it says it does. It creates an error for us. So if we come over here to our app and we open up our dev tools, go to the console. If I click on this toggle button here, we see that it throws the error, could not update. But we don't want this to happen. We don't want our app to just crash. We actually want to handle the error so that we can recover from it and so that our user can continue to use the app as we intended it to be used. So we'll add in the Nuxt error boundary component in our course page. And now when we come over to our app, I'll clear out these errors here so we can see what's going on. If I click on this button, we don't get an error in the console. That's because the Nuxt error boundary sort of absorbs that error. It catches it and prevents it from bubbling up even further to the rest of the app. You'll also notice that our lesson component completely disappeared here. That's because when Nuxt error boundary detects one of these errors, when it catches an error, it will switch from rendering the default slot and instead render the named error slot. So let's add that in now. As soon as we hit save, we see that our app updates to show this error message along with the error that we caught. Now, this error message is kind of vague and not descriptive, but because we have this error boundary around this Nuxt page, and we know that this page renders a lesson, we can give a more specific error message. If we didn't use the Nuxt error boundary component and instead just threw up a generic full page error, we probably wouldn't be able to know that something went wrong with the lesson specifically. And so our error message would have to be very vague. So now we've caught the error, but we want to recover from the error so that we can continue to use the application. To do that, we take this error object that the Nuxt error boundary component passes in to the scoped error slot here, and we reset that value back to null. So we'll add in a button here, and then we'll add in this reset error method. Now when we come over here and we click on this button, the error crashes this part of the app, but then we're able to click on this reset button. and we've restored the functionality of our app. One thing to note here is that if we don't clear this error, but we navigate to new pages, this error message is still shown. And the reason for that is this Nuxt page is the same page, and the course component that's being rendered is actually the same component because Nuxt reuses components intelligently. There's no point in destroying and recreating components unnecessarily, so we reuse as many things as we can. So what happens when we set this error back to null is the exact reverse of what happens when we caught the error in the first place. The error boundary component will re-display, it will re-render the component that's in our default slot. And if the error has been resolved, then this will work perfectly fine. Our component will be re-rendered and we'll be on our way. And in many cases, this will be all that you need. We just need to re-render, try again, and that's all that's needed to fix the error. However, in many cases, resolving the error is actually a bit more complicated, and so we need to do a bit more in order to resolve the error, and that's what we will cover in the next lesson. But before we move on, I need to point out something with this error variable. This error value is actually specific to this Nuxt error boundary component. In the lessons on server-side error handling, we'll see how we can use the useError and clearError methods to work with server-side errors in Nuxt. Those methods operate on server-side errors, not this error. This error here only exists on the client side, and the only way that we can interact with it is through this scoped slot here. So that's why we have to pass it from our scope slot into this error handling method here. So we'll cover these methods more in future lessons in this chapter, but I wanted to point that out in case it causes any confusion. All right, so now we've seen how we can handle client-side errors a bit. Let's move on and look at how we can resolve errors in a more advanced way. Simply re-rendering a component is not always enough to resolve the error. In our last lesson, this is how we resolved our errors, but in this lesson, we're going to take a look at a more advanced way to solve our errors. So we're going to look at a different example of an error that might come up in your application. Here we're going to simulate an error that happens when you open up the third lesson. It only occurs on this third lesson. It doesn't occur on any of the other ones. So what happens here is we're going to try and log out using this method and this parameter that does not exist. And so when this method is called, we're going to get an error, but only on this third lesson. So you can see if we click around, the first two lessons load fine, but then we get to the third one and we get an error. Okay, so no worries, we just hit this reset button, right? No, this doesn't work. And the reason for that is that the error doesn't actually get resolved. We get stuck in this doom loop where we reset the error and then re-render the default slot, which then creates another error. And then no matter what we do, this error keeps coming up and there's no way for us to resolve it just by re-rendering the component. So we have to do something else. This is where it's useful to do a strategic retreat, where we go to somewhere safe. We'll navigate to a different part of the app that is more likely to work correctly. In our case, we're going to navigate to the first lesson. So we'll open up our course page here and come down to our reset error method. And we'll use this navigate to method from Nuxt. And this method works on the client side as well as the server side and lets us do redirects and navigation programmatically. Now, one important thing to note here is that we have to navigate first and then set the error to null. If we tried to do it the opposite way, we would have that same problem. We would still be stuck in that doom loop. So let's see how this works. We'll refresh our app here, and we go to lesson 1, then we go to lesson 2. Lesson 3, we throw this error, but now when we hit the reset button, we're taken to lesson 1, our error is reset, and we're able to continue on. Now, depending on what you are doing with your app, you'll want to resolve your errors differently. And this is going to be highly situation specific. And I can't really go through all the different options and different ways of resolving errors because it's going to depend a lot on what your app is doing in that particular spot. But making sure to actually resolve the error first is incredibly important. One last thing with client-side error handling is that we can actually escalate these errors to fatal errors. So let me show you what that means. We'll update our reset error method here to instead throw a fatal error. So now we'll navigate to the third lesson, and we'll click reset and see what happens. A fatal error. This will create a full page error that works very similarly to server-side errors. And if we put this in the default slot of the Nuxt error boundary component, that component will also catch this error. But these fatal errors are good for cases where there is no way to recover and there is nothing that you can do. So instead, all you've got is to just throw up this full page error and hope for the best. In our next 2 lessons, we'll look at server-side errors and how we can put in a custom error page. But before we finish with this lesson, I want to take a moment to discuss where we might even want to put these different error boundaries. Before I mentioned how we can use the Nuxt error boundary component to isolate distinct parts of our application. And this lets us handle errors in more specific and more useful ways. Now, you shouldn't wrap every single component in your app with this error boundary. That's completely overboard, and you would hate your life after a while if you started doing this. But larger chunks of state do make sense to wrap. So one way to think about this is with child routes. In our app here, we took this lesson child route and wrapped it in a Nuxt error boundary. If you had an admin dashboard with lots of different widgets on the page, like Google Analytics or an app similar to that, you might want to wrap each of those individual widgets with a Nuxt error boundary component. Each app will look different in how you do this, but that's the general way in which I would suggest to think about how to use Nuxt error boundaries. All right, so in our next lesson, we'll take a look at handling server-side errors. In the last couple of lessons, we looked at handling client-side errors. So in this lesson, we're going to take a look at how we can handle server-side errors. If we go to a completely random route in our application, we get a 404 page, just as you'd expect, because the route doesn't actually match anything in our router. However, if we go to a route that matches, but doesn't actually exist, we'll get a different kind of error. This isn't a 404 because it actually is a valid route, but when we go to render the page, the component itself crashes. We can see in our lesson component here that we look for the chapter, but we assume that we found it. And then we go on to use that chapter to find the lesson. But if this chapter is null, then value doesn't exist and lessons don't exist. And so the page crashes. And that's why we have this 500 error here. So to handle this properly, we're going to check to see if we've actually found the chapter. And if not, we're going to throw an error. We'll use the create error method that we saw previously, but this time we'll pass an object to it so we can give it a status code as well as a message. We'll copy this and do a similar thing for the lesson. Now, if we refresh this page, we get this 404 chapter not found error. And although this is technically a 404 error because the chapter isn't found, this error originates from the server, not from the routing portion of the app. That's why it is not showing our 404 page. The router has successfully matched on our lesson route, but when it goes to render the page, that's when this error comes up. So it shows a server-side error instead. However, this error page is the default, and we want to be able to write our own custom error page. In order to do that, we need to add in an error component, but we add that in at the root, not inside of the pages directory. This is because the error component is not part of the router. This error page is shown whenever the server has an unhandled error. And so this is not part of the router, and so we don't put it inside of the pages directory. So we'll add in our page here. And we'll see that our custom error page is now being rendered. Note that we're using the Nuxt layout component here to use the default layout, or whatever it is that happens to be set at that time. We can also use the useError method in order to grab some details about the error that's being displayed. Now we see that it says chapter not found. So we're displaying the error, but like we showed in the client-side error handling, we also need to resolve this error and recover from it so that our user can keep using our application. So we're going to add in a button that the user can click in order to do this. Here, though, we're not going to use a button, but instead an anchor tag, because we will be going to a correct page instead, which we'll see in just a moment. In our handle error method, we are going to use the clear error method that comes with Nuxt. We're also going to use the optional redirect parameter to redirect to the first lesson of the course. Unlike what we did in the previous lessons on client-side error handling, we can clear the error and then navigate to a new page in one step here. And again, to point out that these methods, the clear error and use error method, operate on the server-side error only, and they do not affect or work with the error variable that comes with the Nuxt error boundary component. So let's see this in action. If I click on this link, then we're brought back to the first lesson in the course, and we can go on our merry way, learning and enjoying this course. And if I go to a random lesson that doesn't exist, we'll see that we get the lesson not found error. And then we can recover from that as well. In our next lesson, we'll see a way in which we can improve upon how we handle these errors. In our previous lesson, we looked at how we can use server-side error handling and construct a custom error page for our app. But since the error handling that we're doing here is mostly related to bad routes, we have a better way of doing it. We can use route validation. We'll use the define page meta compiler macro, and we'll add in this validate function. This function is a shorthand for creating specific route middleware. You can return a Boolean or an error, and depending on what you return, we'll either render the route or reject it. We take a look at the route parameters and use that to determine if we're able to actually find the chapter. If we're not able to find this chapter, then we return an error saying that the chapter is not found. This is very similar to what we did in the last lesson, but in this case, we're not waiting until we render the component out. We're doing this beforehand to make sure that we can actually render the page properly. One thing to keep in mind is that because this define page meta is a compiler macro, it's not a regular function. So we're not able to access the course variable that's in this outer scope here. So we have to get it again from this use course composable. As well, we need to return a Boolean. So if you forget to return true here, the page will not render. So let's add in the validation for the lesson as well. Now that we have this validation over here, we can remove the other error handling. And if we go to a route that doesn't work properly, we get the error message that we would expect. It works exactly like it did before, but we've refactored it into a way that makes a little more sense and is a bit more readable. One thing to keep in mind when using this validate function is that it's a specific form of middleware. What's actually happening is this runs a route middleware before this page is executed to determine if we can actually do that. And so if you put in this validate function, you will not be able to run other middleware on this page. However, that's fine for us right now because we don't have any other middleware. But it's just something to keep in mind.
So now we've seen a few things that we can use in order to make our apps more robust. By adding in TypeScript, we can prevent all sorts of small, tedious errors from coming up. In addition to helping us with development, we've seen how we can use the Nuxt error boundary component to help us handle client-side errors. And we've seen how we can handle server-side errors on the server and clear them and deal with them properly. In Chapter 4, we'll be taking a look at route middleware and then using route middleware to add authentication to our application. Now, this is one of the more complex subjects that we'll be tackling in Mastering Nuxt 3, and so it takes us a few more lessons to get there. We'll start out by learning about route middleware, including the differences between inline, named, and global route middleware. Then we'll create a login page for our application, set up Supabase and GitHub so that we can have a provider for our authentication. Then we'll use the Supabase Nuxt module to integrate Supabase with our Nuxt app. And this will let us log in and log out and get some information from our user. Once we've done that, we can now protect certain routes on our app. And for our online course, we'll actually let viewers see the first chapter for free. And every other lesson will be protected by auth. Finally, the last lesson, we'll take a look at understanding OAuth. Since we're using it a bunch in this application, I think it's a good idea to understand a bit more about what OAuth is and what exactly we're using it for in this application.
In this lesson, we're going to take a look at route middleware. Route middleware are run every time before navigating to a specific route. So when we click on a link, a NuxtLink, and when we do any routing in the app, this route middleware is going to be run first. This gives us an opportunity to check some things about the app or the route and to block that navigation from happening, to redirect somewhere else, or to let it happen and not interfere with it at all. Now, this route middleware is distinct from server middleware, which runs inside of Nitro and not on the Vue portion of your app. Server middleware is run on every single request and is more for things like adding information onto the request object. So in my mind, route middleware is a lot more useful and has a lot more use cases, and you'll probably end up using it more than you will server middleware. But with route middleware, because it's run every single time we change the route in our app, it's run on the server side as well as on the client side. Okay, so let's get into actually writing some middleware. So in the previous chapter, we wrote this validate method here that checks to see if the route that we're going to is even a valid route. This validate is syntactic sugar over top of a route middleware. But when you use validate, you cannot use any other route middleware. And this will become a problem for us because we want to add in authentication, which will use route middleware. So we're going to refactor this into a plain regular route middleware. We use this middleware key, and as we see this pop up here, for the type of the middleware, we see that we can add in a string, a navigation guard, which is a method, or an array of string and navigation guards. So we just have one function here, so we're going to just put in that function. We'll make sure to destructure our params off of the route that we're going to. And instead of returning the error directly, we need to wrap it in the abort navigation method. And we'll do that for this other error here as well. And lastly, we just need to remove this return true. If everything works out and we're going to a valid route, we don't need to return anything. Now that we've finished refactoring our validate method into a route middleware, let's test it and make sure that it works. So I'll type in some random route up here. And because we put in a lesson that did not exist, we get lesson not found, exactly as we did before with our validate method. And let me test it with the chapter as well. Chapter not found. Perfect. So our route middleware is working as we expect it to. So let's take a second to look into what route middleware are actually doing. So they do have a specific format that we need to follow. We get a route that we're going to, and then we get a route that we're coming from. This is useful to do different validation in different circumstances. And then we need to return one of three things, or we need to do one of three things. Either we do nothing, and we let the route navigation proceed as normal, or we return navigate to and do a redirect, or third, we can return this abort navigation method with an error, which will stop the navigation altogether. In our middleware here, we check to see if the chapter and the lesson exist. And if they don't, we return an error with abort navigation. And if it all looks good, we do nothing. There's no return here. We just let it happen. In this middleware, we're not doing any redirects because we don't need to. So those are the three things that you can do inside of a route middleware. In the next lesson, we're going to create our login page, and then from there, we'll be able to combine this route middleware and authentication with Supabase to lock down specific parts of our application. In this lesson, we'll create our login page as well as add in a couple other things that we need to before we can move on. So our login page will live right at the root. So we'll put that in here. And then I will copy in the code for that. And this component is fairly straightforward. We're just going to have a header and then a button that says login with GitHub, which we will implement in a later lesson in this chapter. And if we navigate to that, we can see what it looks like. A header with a button. Nothing too crazy right now. I'm also going to go to the course page here. And I'm going to wrap this in a single div because right now we have multiple root nodes. And although that works, there are some issues with having multiple root nodes, and wrapping in a single root node will let us do route transitions properly and will make it easier to add in some other things later on. And since I'm using Prettier, I don't have to worry about indentation and all that kind of stuff. Just hit save and it reformats it for me. If you do not have Prettier installed, you can add it in as an extension on VS Code. And then enabling it for your application is very straightforward as well. You just have to go into the settings. And if you do format, you have to enable format on save. And then when you search for formatter, you can set the default formatter to be Prettier. And so now every time you save, it will format using Prettier. You can change these settings on a per language basis. If you want Prettier for JavaScript files and TypeScript files, but not for HTML files or CSS. But I'll let you figure that out on your own. One more thing I want to do on this page is, you may have noticed that we're still using this mastering Nuxt 3 here, even though we have a title for the course. So I'm going to fix this up here as well. And now we get TypeScript with Vue.js. the title of the course that we're putting together here. One last thing that I want to fix up that I've noticed as I have been developing with this little app as we go along is that the root page has nothing on it. And sometimes it's tricky to type out this full path to get to the correct place in our app. So let's add in a link so that we can go straight from the home page right into the first lesson. I'll open up the page here and paste in some markup. And then I'm going to add in this composable use first lesson, which does not exist yet, but we will create it right now. So instead of grabbing the use course composable and then needing to filter for the first lesson all the time, there are a bunch of places where we're just grabbing the first lesson. So why don't we create a composable to make this much easier for ourselves? This composable is pretty straightforward. We'll grab the chapters from use course, and then we just get the first chapter and the first lesson. Then we crashed our dev server, so we need to restart that so it will pick up these changes properly. And now everything should work. There we go. Go to first lesson. We click on that and we're back into our app. So that's just a simple quality of life thing as we continue on with this course. In the next lesson, we'll take a look at inline, named, and global route middleware, and we'll see the differences between them and when you might want to use each one. In this lesson, we're going to take a look at creating a basic auth middleware. It won't actually do proper authentication. We're just going to redirect to the login page. But through that, we'll be able to see how inline middleware, named middleware, and global middleware all work. So first, we're going to add a middleware to this lesson page. And because we've already got a function in here, we actually need to create this as an array. So we'll put some square brackets around this. And we'll add in our second middleware. For our course app, we're going to make the first chapter freely available. In the same way that Vue School has different lessons that are available for free. But then the rest of the chapters in the course will be locked down, and you can only access them if you have bought the course. So a simple little way of doing some marketing and giving out a sample of what we're selling here. So our logic here is to check the chapter slug, and if we're on the first chapter, we don't care. We're just going to let the navigation happen. We're not going to do anything. We're not going to restrict access. However, if we're on any other chapter, we're going to redirect straight back to the login page. In a later lesson, we'll actually hook this up to some real authentication logic that checks if the user is logged in first. But for now, this will show how to use the middleware. So if we come over to our app here, we can check out different lessons in the first chapter. But as soon as we go over to chapter 2, we get redirected straight to the login page. But one interesting thing to note is that the order of how you define this middleware makes a big difference because the middleware is run in this order. So if we try to go to an incorrect route, we are not redirected to the login page. We simply get this error from this first middleware. This type of middleware that we've been creating here, these two methods, are inline middleware. We're defining them inline in the page. And these are great for if you need some one-off logic for a particular page and you don't need it anywhere else. So in our case, we only need this route validation here that checks for a chapter and a lesson on this page. So it makes sense as inline middleware. However, this auth middleware here, we're going to want to use that on other places in our application. So we don't want to copy and paste this around. We want to move that into a named middleware file. To do this, we'll first create a file in the middleware directory. Right now, we don't have a middleware directory yet, so we will first create that. And I created it in the wrong spot, so I'll just drag that up. And then inside of that middleware directory, we'll create our auth.ts file. In order to create our middleware, we need to use the define Nuxt route middleware helper. If you ran this command using Nuxi, it would actually scaffold this out for us. So let's quickly see how that looks. If we open up our test middleware, we can see that it creates this little wrapper using the define Nuxt route middleware method. So we'll just get rid of that for now because we don't actually need it. And we'll add in the logic that we had before in here. And in order to run this in our lesson page, we simply need to use the name of that middleware, which is why they're called named middleware. And the only middleware that we have is auth. So that's the name we're going to use. And once we save, we can see that this middleware indeed works as we expect it to. Named middleware is great because we're able to add it to multiple pages without needing to copy and paste code all over the place. You may have noticed that we've got this big function here and then a string in this array. And it's kind of unreadable. So ideally, we would be able to extract this function out and then reference it in our middleware auth. And this is much easier to read, and you would be right for thinking that this is a more readable piece of code. However, define page meta is a compiler macro, meaning this isn't actually run as JavaScript. When Vue is compiling your code, it will extract this piece out and replace it with some other code. This means that we can't define our function outside and then reference it in here because these are disconnected. This is why we have to use the use course composable a second time, even though we've defined it out here already. This is by no means a deal breaker, but it is important to keep in mind as you are developing your inline middleware. Now we have one more type of route middleware to discuss, and that is global middleware. In order to create a global middleware, all we need to do is add .global as a suffix to our file name. And now, this middleware will be run on every single route change. So if you have something that you want to be done on every single route change regardless, then this is perfect. However, if we come over here, we can see that we have an infinite redirect. So that's one problem with global middleware that you have to watch out for, in that we can lead to infinite redirects because we're constantly running this middleware over and over again. So we'll remove that off of there so we don't run it on every single one. And let's create a different middleware that we can use to illustrate how this might work. We're going to use the use local storage composable that we have already worked with, and we'll create a middleware that will actually track the different pages that our user has been to. We'll need to restart our dev server here. Not sure why we get this error here. But if we come to our composable, we can see that we get a lot of different routes being printed out to the console. And the reason that there's so many is because I was playing around with this before, and so it's been tracking me for a while already. So I will quickly come over here and clear it out. Here we go. History. Delete that. Okay. So now, if we go around on our app, it will keep track of the different route changes that we do. If you wanted to create your own analytics tracking system for your app, this might be how you do it. Global middleware in this way is great for gathering data, for logging, and other telemetry like that. If you want to know, why do my users stop watching videos, you can use this to maybe get a bit more insight into that. Of course, there are lots of other use cases for global middleware. We'll keep this middleware running, but we're going to remove this console log because otherwise it will pollute our dev tools, and we don't want that. Now that we've gone through route middleware and we understand inline and named and global route middleware, and we've even created a sort of fake auth middleware, our next step is to actually hook it up to some authentication. And we're going to do that using Supabase in the next few lessons. So that's the next one, setting up Supabase so we can actually do authentication. In this lesson, we will be creating our project in Supabase, which will let us set up authentication. And in a future chapter, it will let us set up a database that we can start to store data in. We're going to be setting up our Supabase authentication with a GitHub OAuth provider. So we'll be in Supabase and GitHub for this lesson. So let's get started. First, you'll want to come up to the top here and sign in. I'm already signed in with my GitHub account. And from there, you're going to create a new project. And then choose a name that you like. For right now, we don't need to worry about what the database password is, and Supabase makes it pretty easy to change the password later on if you forget it or misplace it or something like that. So for now, we're just going to hit generate password so we have something. And again, we don't need the database password yet, so I'm not even going to bother with copying it and saving it somewhere. Supabase takes a few minutes to spin up our database as we need the database in order to use the authentication. But since we have our API keys here, we can actually get started setting up our GitHub OAuth provider. So we'll come over to the side here, and you can see that we have a whole bunch of different options here. We've got the table editor, the SQL editor, and those are just nice UIs that we can use to access our database. Then we have the database, authentication, storage, and edge functions. Those are the 4 main products that Supabase offers us. In this course, we will only be looking at the database and authentication. So we can see now that our project has spun up. So let's go into the authentication tab. Then we're going to click under providers. And here we have all of the different authentication providers that we can use with Supabase. By default, Supabase will just use email-based authentication. This means that Supabase will be keeping track of the passwords and usernames for your users in your database that we just spun up. But that's a little bit more complicated and requires everyone to create yet another account. So instead, we're just going to use the GitHub provider. This lets us reuse everyone's existing GitHub account. Just as you logged into Supabase with your GitHub account, we can log into our online course platform with the GitHub account that we already have. So we first enable this, and then we need to copy the redirect URL. We need this redirect URL when we set up our GitHub OAuth app. So now we need to go into GitHub. And what we need to do is create an OAuth app. And this app is what Supabase will communicate with. We'll go up to the top here, go down into settings, then scroll all the way down here to developer settings. We'll create a new GitHub app. And I just need to do some 2-factor authentication. You may need to do some 2-factor authentication like I do here. So I will just hit this and put in my code. We'll use the same name that we were before with our Supabase app, or our Supabase project, sorry. For the homepage URL, we'll use the base of the URL that we copied from our Supabase. And then in here, we need to use the callback URL. We'll paste that in, ending with auth/v1/callback. And then we need to come down here and we actually need to uncheck this webhook. We don't need any permissions to actually access the GitHub user here. If we wanted to, we could add that in. If we needed to check out code or put in commits or approve PRs, things like that. However, since we're only using the GitHub OAuth system in order to authenticate our users, we can skip this part entirely. Next, we'll need to generate a client secret so that we can properly authenticate between the apps. Now we want to copy this secret and go back to our Supabase setup. And here where it says client secret, we're going to paste that in. We also need to update the client ID here with the ID that GitHub has given us. Then we hit save, and we should be good to go. Now we have GitHub and Supabase successfully linked together so that when we use Supabase for authentication, we can actually use GitHub as an OAuth provider so that we can use GitHub accounts in order to authenticate our users without having to deal with managing accounts ourselves. In order to actually use Supabase within our app, though, we will be using the Nuxt Supabase module. This uses the Supabase JavaScript SDK, but then wraps it in reactive composables and gives support for SSR. So we'll come back to our project here. We will open up a new terminal and install the Supabase Nuxt.js module. Now, as we've seen with the Vue use module that we added before, once we've installed it, we now need to add it to the Nuxt config. Once we save, our app reloads and we can see that we get an error. The Supabase URL is required. So there's some further setup that we need to do in order to get our Supabase module to actually connect with our Supabase project. We will tackle that in the next lesson where we'll look at environment variables and how we can use them in our Nuxt app. In our last lesson, we set up our Supabase project and connected it with our GitHub account so that we can use GitHub as an OAuth provider. But we're not completely finished setting up Supabase, so we'll finish that up in this lesson. Here we have the installation instructions from the Nuxt Supabase module, and you can see that we have done the first few steps here. We've installed the dependency, and then we have gone and added it to our config, but we haven't added the right variables to the environment file. And so one question you might have here is, why don't we just add these values into the Nuxt config itself? There are two main reasons that we use environment variables. The first is that we don't want to store potentially sensitive data in our code. Git repos are not designed to store secrets like this, and so we might accidentally expose them or leak them out in some way. And it's just better to keep them all in one spot where we know we can have stricter controls around those sensitive pieces of data. The second is that we want to separate our configuration from our code. Here we have the Supabase URL that points to our Supabase project. In production, we will have one Supabase app that's got all the production data from our users, and that will need to be kept running, and we'll need to keep that data intact and make sure that we don't do anything weird with that or accidentally delete it. But we can also point that to a dev instance for when we're developing, where we can mess around with the data. If we accidentally delete it, it's not a big deal. We might also want to put up a staging environment so that we can test out changes and collaborate with our team before pushing that feature out onto our production server. And sometimes we might even have an extra environment or two for end-to-end testing or UI testing if we're using a tool like Cypress, for example. And so by keeping this data in an environment variable that's separate from what goes into Git, we can more easily change these things as we need to and keep our potentially sensitive secrets safe. So if we come over here and run pnpm dev, we'll see that it starts up, but we're going to get a warning here because we're missing the Supabase URL and the Supabase key. So let's add those in now. We create our .env file at the root level of our project. And then we have to grab the relevant data. We'll come over to our Supabase project. We'll go into settings and then into API. And here we'll be able to find all of the right settings and URLs that we need. So we'll just copy this so we make sure to get the key names right. We'll copy the project URL and pop that in here. And then this key is this anonymous public key here. It is not the secret key here. And this key here actually is a JWT token, if you can recognize this format here. So we'll save that. And if we run git status, you'll notice that it doesn't show up with anything. And that's because Git ignores these .env files because we don't want to actually store it with our code. So now we do not get that error because we've added in the Supabase values correctly. And our app is now running as it should. At this point, we're able to use Supabase, but only locally when we're developing. As soon as we push to Netlify, we won't be able to access these environment variables anymore because this .env file only exists on our local machine here. To fix that, we can use the Netlify CLI to export the .env and upload that to Netlify. We'll add it as a global dependency so that we can run it as a command wherever we want. Then run netlify login. And I'm already logged in on this machine. But for you, on the first run, you'll need to log in with your Netlify account. Once you have done that, all you need to do is run netlify link. Netlify link will create a special folder in your Git repo, which will link it to a specific Netlify project. And you have a few options here. You can do it automatically, so it can automatically detect which Git repo you are currently in and which you've deployed from, so it can link those without you having to do anything. But if not, you can also select from a list. So it's pretty straightforward in that way. Once you've linked it, then we run netlify env import. And this is the command that grabs the values from the .env and uploads them to Netlify. So this formatting here kind of got messed up because it's zoomed in here. But you can see it's a table of data there. We can go to our Netlify project and see how it's added it in. So now in settings, we go to our environment variables, and we can see that we now have a Supabase key and Supabase URL in our Netlify project. We can modify these values directly in here if we want to use different values as discussed before. We can have a separate values for development and then a separate value for production. And Netlify supports having different values based on the context, whether you're in production or deploy preview. And so if you want, you can go and configure that yourself, but we're just going to stick with the one value for this course. Now we've finally set up everything that we need in order to use Supabase to do the authentication for our app. Now I'm going to recreate my project here so that we get different values in here, because now that this is exposed, I don't want to risk anything with that. So I will recreate that project and see you in the next lesson. In this lesson, we are finally going to implement the login function for our app. Now that we've gone through all the work of setting up our Supabase project and connecting it with GitHub and building out our login page, now we can tie all these elements together and log in with GitHub. But first, I want to clarify something between authentication and authorization. So these are two distinct concepts, and they're both shortened to auth, which makes things a little confusing at times. But the difference is this: authentication is about identity. It's about proving who you are, whereas authorization is about restricting access based on that identity. So in this chapter, we're going to be focused on the authentication part of the puzzle, where we will use GitHub to help identify who our users are. Later on in the course, once we've implemented the checkout process, we can then use authorization to determine if that user is allowed to access the course or not. One thing that we need to update before we can get into this is a permission in our GitHub OAuth app. So if you go back to your developer settings, then select your Mastering Nuxt 3 OAuth app, which we just created, we'll need to come into the account permissions here, down to email addresses, and then set the access level to read only. Once we do this, then we'll be able to use this app properly with our application. So let's implement the login method now. Now I'm just going to copy and paste this guy in. We missed an end bracket there, so I'll put that there. And at the top, we're going to grab our Supabase client using the use Supabase client composable. And from there, we can access all of our auth methods. The one we're going to use is the sign in with OAuth method. And we're going to give it the provider of GitHub. Now, if you remember in our Supabase project, we had that whole long list of OAuth providers that we could enable. And we can provide any one of them in here. Now, you might want to eventually add on additional OAuth providers, in which case you could switch between them in this case. Then we add in a bit of error handling, and that's it. We don't really need to do a lot in order to log in using Supabase, which is one of the reasons why I love it so much. I could have chosen Firebase, which is another popular alternative. If we were to use Firebase with this instead, the process is actually very similar, but we might have to do a little bit more work in order to build ourselves some composables and get things to work in a nice manner. But with the Supabase Nuxt module, we get a lot of this stuff done for us, and so it's very simple and straightforward. So now we actually need to hook up this login button to the login method, and we're good to go. Now, if we hit login with GitHub, we'll see that we are redirected back to our home page. What happens in the background with OAuth is that our application redirects to GitHub, and then GitHub can determine who we are, and then redirects back to our application with a token, and that token contains information about the user. But if we go into our app, we see we're not doing anything with that information yet. So our next step is to add in a user card that we can display right in this top corner here. So let's add that in right now. This component will grab the current user using the useSupabase user composable. Then with some computed methods, we extract the name and the profile from that user object that GitHub gives back to us. And then, if the user exists, we'll display the card showing the profile picture, their name, and then giving a logout button as well. Now, a side note about this component and the way that it's designed, we could have built it with props so that we have to pass in this user object, but then the component isn't self-contained. And it's actually really nice if a component like this is completely self-contained, because no props are actually a lot easier than one prop or even two props. And so by making it self-contained, we make it a lot more reusable and easier to put into different parts of our application if we ever wanted to do that. So I save that, and we'll add it into our course page here. And we'll see that it's actually pretty straightforward because we don't need to grab that user object. At the same time, I need to update how this div is styled in order to get the layout to work correctly for us. But as you can see now, we have our user card displayed in the top right here. Displays my name, profile, and then a logout button that currently does nothing. One important thing to note is how we actually do the login process, how it keeps track. And so if we open up our dev tools and go into the application tab, we can see that there is this SB auth token here. And this is for Supabase. And this token is the access token for us. If you want to look into this further, you can learn more about JWT or JSON Web Tokens and how they work. But we can see that this access token has some extra information along with when it will expire and when we'll need to get a new token, as well as how to get that token. But you can see that we also have this user object on it. And this is the GitHub user. And so we can see we have all of this extra metadata, email confirmed at. And so this is all the information that we're getting back from GitHub. In this lesson, we've shown how we can log in to our application using GitHub, but we also need to do the opposite action. We need to be able to log out as well. And that's exactly what we'll cover in the next lesson. In the last lesson, we saw how to log in, and this one, we're going to implement logging out of our application. But first, we're going to fix a small little typo that I put in by accident. So if we come down in our user card component, we see that we're getting this red squiggle for an error. And that's because we've got TypeScript enabled on this component. And if we hover over, we see that object is possibly null. And the error here is that I put this optional chaining on the wrong section. So it should be after the value, because user will always have value because it's a ref. It's just whether or not the value itself is null or not. So now that we've fixed that up, we can continue on and log out. So the simplest way to handle this is to simply redirect back to the login page. It can get more complicated because with our app, we have the first chapter as free, and then every other chapter we want to protect behind this authentication. And I did explore making the app so that we could, when we log out, it will first check to see if we're on a protected chapter or not. But ultimately, that actually makes it more complicated than it needs to be. And the logic gets really unwieldy, and it's actually better and much simpler to just redirect back to this login page. Ultimately, if someone is logging out, they're probably not interested in continuing with course lessons anyway. So from a UX perspective, this also is the simplest. Our logout method looks very similar to the login method that we had previously. And I'll just copy and paste this one in. We do have a couple slight differences. The first is that instead of grabbing the auth off of the client, we're just going to destructure it right away because that's all we need in this component. And then at the very end, we're going to use our navigate to method. And we're going to go back to this login page. So once we add that in, if we refresh our page and we log in, go to the first lesson, we see that we're logged in. And then if we hit log out, we're taken back to the login page. But if we hit the back button, we see that we're in the app, but we're not logged in. So this works exactly as we want it to. However, we do have a slight issue, and that's to do with how the session for our user is handled between the client and the server. So I actually just did a bit of sleight of hand here. I refreshed the page in between. You may not have noticed that, but if I go back to the login page, if I log in, go to the first lesson, we're logged in, but we're still on the client side. We haven't hit the server yet. If I, without refreshing the page, come back to this logout button, and then we go back again, we'll see that we're still logged in. What causes this error is that the Supabase module doesn't properly update the session on the server side. But when we refresh the page, that does get refreshed. Now, I spent many hours trying to solve this issue and get to the bottom of it. And I dug through the Supabase module code and dug around for many hours. And I simply could not figure out how to get this to work properly. Instead, I came up with a workaround, a bit of a hack, if you will. What this does is simulates what the Nuxt Supabase auth module should be doing, and that is posting to this endpoint and telling the Supabase module that we are now signed out. This is a great instance of putting in a hack that is not really the ideal way of writing the code, and ideally you'd be able to figure out why the Nuxt Supabase module is doing this. Maybe we've configured something wrong. Maybe it's a bug in the auth module itself. I don't know. But occasionally you will need to simply get the thing to work, to ship it. We've all got deadlines. We all have targets that we're trying to hit. We're trying to roll new features out. And we don't always have the time or the ability to figure everything out 100% and make the code perfect. So sometimes you just have to put in a hack like this, get the code to work, and then move on. Now, hopefully in the future, we'd be able to come back to this, refactor it, clean it up. But for now, the code works. And that's the most important part. So I'll just do a quick demo of this so we can see. If I log out, we go back here. So we'll do the full thing again. We'll log in. go to our first lesson. And now without refreshing the page, I'm going to hit log out. And if I hit the back button, you can see that we are now properly logged out of our application. So now that we have login and log out working, the one thing that we are missing is that even though we're logged in, if I try and go to chapter 2, we're redirected back to the login page. And that's because our route middleware does not check to see if we have a user logged in. So that's what we're going to cover in the next lesson. In this lesson, we're going to do 2 final things in order to finish up our auth for this app. The first thing is to update our route middleware so that we're actually checking for a user to see if we're logged in or not. And the final thing is to provide redirects so that when we're logging in, we get redirected back to the spot that we were trying to go to in the first place. To update our route middleware, we need to open up the file first. We'll grab our user from the use Supabase user composable. And then we'll add into this condition here, if the user is active, if the user exists, then we're going to not do anything. So if the user is logged in, we'll be able to go anywhere in the app. But if the user is not logged in, we'll only allow access to that first chapter. Otherwise, we'll redirect to our login page. Now let's check to see if this works as expected. So if we log in, we can go around onto the first chapter, and we can go to the second and third chapters. However, once we log out, we can click around on the first chapter, but as soon as we try and go to the second chapter, we're redirected back to the login page. So this is the thing that we've been trying to achieve and do this entire chapter, and it took us a while, but we finally got all the pieces together in order to do authentication. But that's just the first piece that we wanted to tackle in this lesson. Because if we go back to our app here, if we want to go to lesson 2 of chapter 2, but we're not logged in yet, the user experience is a bit janky. So we click on the link, we're brought to the login page, we log in, and I need to reauthorize because GitHub is wondering why I'm logging in and out so much. And we're brought back to the home page, but that's not where I wanted to go. I wanted to go to the second lesson of the second chapter. And so I'd have to click on this and then click here again. What we want to do instead is that as soon as we've logged in, we're redirected right back to this route, to the route that we were trying to go to in the first place. In order to do this, we're going to keep track of that route in our query. So in the middleware here, we get this route of where we're trying to go to. And instead of just redirecting straight to the login page, we're actually going to add that query parameter on. We're going to take that full path and add it to a redirect to query. Then in our login page, we can grab that query and use it to redirect properly. First, we'll need to grab the query from the route. Then, in order to construct the URL that we want to redirect to, we take the origin of where we currently are and that query parameter that we passed from our middleware. The sign in with OAuth method has a redirect to option, which we need to pass. From there, we need to add in a watch effect, which will watch to see if the user switches from logged out to logged in. We also need to grab the Supabase user in order to make this work. So what this watch effect does is it will run immediately because it's a watch effect and not just a basic watch. And then if we have a user that's logged in, we will redirect to wherever this redirect to query tells us to. The reason that we need to have this in here, and we can't just rely on the redirect to in the Supabase method here, is that when Supabase redirects us back to where we want it to go, the middleware does not yet know that we're logged in. And so it kicks us back into the login page yet again. My suspicion is that it's the same session syncing issue that we ran into when logging out. And the same thing applies here. This piece of code enables it to work. And so we're going to go with that. And so to see it working, we're going to log out of our app. Then we'll navigate to the first lesson here. And then as you can see, we click around on the first chapter, we're able to see it just fine. But then when we go to chapter 2, we're redirected to the login page, but we've got that redirect to query param in here. Then we hit login with GitHub. And magically, we're logged in and redirected right back to chapter 2, lesson 2, and we're logged in. So now we've added a bit of a nice UX polish on top of this, and our users will be happy because they don't have to click around all the time, and it just works nicely. In this chapter, we've been talking a lot about OAuth. We've seen in Supabase, we have a ton of different OAuth providers, including GitHub and many, many others. And so in the next lesson, I'm going to take some time and explain what OAuth is at a high level and how we're using it in this application. And that will be the last lesson in this chapter. In this lesson, we're going to take a deep dive into OAuth. So we spent most of this chapter working with OAuth and setting up GitHub providers for OAuth, using Supabase in order to interact between our app and that GitHub app. But we haven't really talked about what OAuth is or how we're using it in this application. So why do we even need OAuth in the first place? The main reason is that we want to stop sharing login credentials with our applications. We only want to enter in the password on the service itself. Instead, with OAuth, we're able to share tokens that represent that permission to log in somewhere. And it helps a lot that this is a widely adopted industry standard. So whenever we're interacting with logins and credentials, we're able to use OAuth and understand how OAuth works because it's used practically everywhere. So let's imagine that we are trying to build ourselves a Twitter bot. So on the left, we've got the user, myself here, and I'm going to interact with the bot. I'm going to set it up, configure it to post hourly or daily or whatever it is that I want to do. And then that bot is going to interact with Twitter and do all the posting on my behalf. In the past, before OAuth, I would have to take my username and password and send it over to the Twitter bot so that the Twitter bot could then use that username and password on Twitter. And now the bot is able to log in into my account and post, like things, retweet, all of that. However, if that bot turns evil, it still has our username and password, which is not a good thing. So to avoid that, the industry came up with this idea of OAuth. We have you as the user. We have the bot, which we call a client or third-party application. Then we have the resource server. This is the thing that we want to access. So this would be the Twitter timeline, being able to post new tweets, retweet. That's what the resource server is. It's the thing that we actually want to access. The real innovation with OAuth comes with this addition of the authorization server. Now, before we talked about the difference between authentication and authorization. And authorization is the process of determining if someone can access something. And that's exactly what this server does. It's a separate server, and its only job is to determine, can this user access this resource? In our app, we're not using Twitter, but we're accessing GitHub instead. And so the flow works something like this. We want to log in through our app, so we hit the login button. Then our app redirects to the GitHub authorization server. Here, we log in to GitHub. And if we're already logged in, then GitHub knows this and it can check, and it will just redirect us back once we've logged in. But when we redirect back to the app, it actually gives us this access token. And this access token is the key to the whole process. Because once we have that token, we can then, from our app, access the resource server. So with our Twitter bot example, once we have logged in and gotten that access token, we can then use that token when we want to make tweets, when we want to retweet, when we want to like. And that access token is what the resource server is expecting. This access token represents our permission to actually interact with it. And in this way, OAuth lets us avoid the need of passing around our username and password. And instead of passing these credentials around everywhere, we instead pass around this access token. For the purposes of our application with the online course platform, we're not actually accessing this resource server. So we're using the OAuth flow in a little bit of a simpler way. We're not creating PRs, we're not closing issues, we're not needing to do any of that kind of stuff on GitHub. So all that we're doing is using the fact that GitHub has this authorization server, which can tell us, yes, this person is Michael Thiessen. And once we get that access token back, then we can look at it and say, oh, okay, we know who this person is. And once we get this access token, we can verify that this person does indeed have access to the online course. So let's dig into what this access token looks like and the response that we get from the authorization server. So in our app here, if we open up the application tab and we go into local storage, if we find this key here that starts with SB-, we get the response that Supabase stores in local storage. What we get back from the authorization server is this access token. When that token expires, a refresh token, the type of the token, which is typically just bearer, and then this extra field for the user. Technically, according to the OAuth standard, this access token can be anything, because all that this access token really is a way for the authorization server to communicate with the resource server and tell it that this is, in fact, an authorized person. So since our app is not necessarily needing to inspect this, it doesn't have to be anything specific. but in most cases, this string here is a JSON web token. And so we can copy and paste this whole token. And if we go over to jwt.io, we can paste our token in and it will decode it for us so we can see what's going on here. The first part of our token is the header, which describes how it's been encoded and other metadata like that. Then the bulk of it is the payload. This is all of the metadata, the data about the authenticated user, and information about the token itself. Finally, at the end, we have the signature. The signature is really important because it allows us to verify that this payload was not tampered with, that this token is the correct token, and it allows us to verify that it came from the right spot. So the token is created using the header, the payload, and the secret, which would be shared between the authorization server and the app that we're working with. Because they share the same secret, and because this signature is calculated using the payload, if any one of these things is off, the signature will not be correct, and we can know that. And so the signature gives us some security in knowing that this token is still a good token. But the interesting part here is what's in the payload. The first few fields here in this payload are standard OAuth claims. And these are used in order to determine the audience, who the token is for, the expiration time, and the user of this token. And these fields are mostly useful for, again, communicating between the authorization server and the resource server. So as app developers ourselves, we don't need to concern ourselves with these values as much. The interesting part for us comes with all of this extra metadata. And this extra metadata here is really the reason why we're using OAuth in order to authenticate with our application. Because we get the email, we get the phone number if that's created with the GitHub account. We get the profile image, if they're verified, the full name, all this extra information, which is what we need in our app in order to determine if the person has access to the course. We can match based on the email address, for example. So now we've dug into what this token is, typically a JSON web token, but could be anything. We've seen how JSON web tokens work a little bit. And if you want to know more, you can go to jwt.io, and there's lots of articles there on what JWT is and how it works if you want to learn more. One thing that's important to talk about too is this idea of a refresh token. So what most OAuth providers do is they set an expiration time on the token. Once the access token is expired, then we have to use this refresh token to go back to the authorization server and get a new access token. And the reason that we expire tokens like this is because it's possible that tokens can get leaked out. So for example, I have pasted this token into this video for you all to see. And so if this token never expired, you could, in theory, copy this whole thing and then potentially hijack my session or do something nefarious like that. But because this token expires in 3,600 seconds, by the time I've uploaded this video, it will already be expired and you won't be able to do anything like that. So it adds a layer of security for us. However, if we had to log in every few minutes over and over again, That would be a very terrible user experience. And so instead of requiring the user to do that, we provide this refresh token. And this refresh token allows the app to get a new token and log back in again quietly in the background without needing the user to intervene at all. So as you're going around with the app is using this refresh token to get a new token whenever it needs to. And so this is one of those things that Supabase is handling for us. You can see that it starts to get very complicated as you dig into it. We have to deal with all these layers of security and all this stuff. And so it's really nice to have a library that does this for us. I've actually had to implement an OAuth flow like this from scratch before, and it's not the most fun thing to do. It's actually quite tedious, and it forced me to learn this and to understand it, but ideally, we can just use a Supabase module that does it for us. The final major piece of this OAuth flow that I want to discuss before we end this lesson is how tokens get revoked. So as you go about using your GitHub account, over time you log into more and more things with that GitHub account. You log into Mastering Nuxt 3. You go onto this online course platform and use that to log in. Maybe you use this for several other apps that use GitHub as the OAuth provider. Eventually, you have all of these different apps that you've allowed to access your GitHub account in different ways. At some point, you may want to revoke that access and prevent that app from continuing to access your data. So if we come into GitHub, we can revoke the tokens and prevent the app from continuing to access our profile. We'll go down to Settings and Applications, and we'll go over to Authorized OAuth Apps. And you can see here that I have 16 different applications that I've authorized to use with my GitHub account. We've got Auth0 for authentication, Code Sandbox, Mastering Nuxt, Netlify. I have an integration with Notion, Rollbar, StackBlitz. We've got a lot of different things here. And as I go through this, I can see, oh, there's a lot of things that I potentially don't need, yet they continue to be able to access my profile. But from here, I can, for example, come in and revoke access. And what this does is it will prevent that application from using its refresh token to get a new access token. And in that way, we continue to have, as the user, we continue to have control over what applications can access our data. If we had instead given it our login credentials, the username and password, we would have to change the username and password to prevent that application from logging in. But with OAuth, because we use access tokens instead as an abstraction for login credentials, we can revoke those access tokens on a per app basis. And so this gives us a lot more security and a lot more control, and it's just a better system for dealing with authentication, and especially OAuth is a very complicated and deep subject. And luckily for us with Supabase, we don't need to know a lot about it in order to use it. However, if you do want to dig deeper, there are some great resources online. OAuth.com gives you a whole book on understanding OAuth in the deepest sense, as well as jwt.io to learn about JSON web tokens, as we saw before. And I'm sure there's lots of great YouTube videos and other things like that out there as well on OAuth. But again, this concept is not necessary in order to build production applications. I only recently learned how OAuth works, and I struggled for a very long time to understand OAuth, and only recently did it click for me. So if you don't understand it completely, that's fine. As long as you understand the basics and the reason why we have OAuth in the first place, and you can use Supabase or Firebase or whatever tool it is that you want in order to do authentication in your app, then in my mind, that is good enough. Now that you've made it all the way to the end of chapter 4, you should understand a lot more about authentication and using it along with route middleware in Nuxt 3. We covered inline, named, and global route middleware, as well as setting up Supabase and GitHub in order to add the authentication that we need into our application. Finally, we also took a look at OAuth, and although we didn't get super deep into OAuth, which is a very complex subject in and of itself, we did see a bit about how it works and why we need it. In this lesson, we'll be taking a look at how server routes in Nuxt 3 work. We're also going to use a tool called Hopscotch to help us develop these routes. If you've ever worked on a server API, it can be really annoying to constantly need to go into our page and manufacture these fetch requests in order to test that the server is doing what it should. So there are tools like Postman and Hopscotch, which allow us to more easily test these endpoints. So in this course, we're going to be using this tool called Hopscotch. Hopscotch.io is where you can find it. And it runs in your browser, but lets you still make requests to your local host, which is really cool. It's also built using Nuxt, which I think works perfectly for this course. A fun fact for you is that Hopscotch used to be called Postwoman, and in the very first course that I created, Clean Components, I actually did a series of screencasts where we went into Postwoman and looked at the source code and did some interesting things there. So for me, this also makes a lot of sense to use this, and it's a great tool. So before we actually are able to use the tool Hopscotch, we first need to create our endpoint. So we'll do that using Nuxi. If we come over to our terminal, we'll type in Nuxi add API world. And you'll see that this was created in the server/API directory. And if we open this up, we can see that we use the define event handler method. And then inside of that, all that we're doing is creating this function that returns a string. So pretty straightforward. To see how this request works, we're going to create a collection in Hopscotch to organize all of these different requests that we're going to be making. So naturally, we will call it Mastering Nuxt 3. And then inside of there, we will do Hello World. And now you can see that we've got this request inside of Mastering Nuxt 3 folder. This green dot shows that we're active on the request. So that's a bit of a confusing part, or it confused me at least, with this UI, is that you need to make sure that this green dot is on. If you click on it a second time, then now we're not in any specific request. And the changes that you do will be for any new request you want to make. So make sure that you've clicked on this. Now it's showing that green dot. And then we can type in HTTP localhost 3000. And then our API lives at /API/world, the name of the file. So I hit send, and we can see that the response is hello world, exactly what we wanted. So I'll add an exclamation mark there. If we send it again, you can see that that updates in there. Okay, so that's the very most basic way of creating a server endpoint. All right, so now we've created the most basic endpoint that we could possibly imagine. One thing to know about the server is that all of these live in the /API directory. But this is actually a shorthand. It's equivalent to if we had the server /routes/API. So if I move that over, you can see that we're in now server /routes/API. And if I send this request, we get the same thing back. So this lets us put any routes that we want in this server /routes folder. If we don't want this API prefix, we can move this into the top folder here, into routes. And then if we remove that from here, we get the same request back. And so you can see that the routing system here is actually the same as what we were using in our pages directory. And in fact, it's the exact same thing. We can even put in route parameters and optional segments the same way that we would with our page routing. But it's a good convention to keep our API routes prefixed with this API here. So we're going to move that back. And we'll use this shorthand instead, just because it's a little bit nicer and easier to work with. So now we need to create our actual API endpoints. So let's think through this for a moment. The data that we need to access in our course is the data for the current lesson that we're on. And so maybe we could create an endpoint for that, a lesson endpoint that matches the same endpoint or route that the pages are using. And the second thing that we need is some metadata about the course so that we can get a list of all of the lessons so that we can render the navigation on the left-hand side, as well as the name of the course, since we're using that on every single page. So we'll be able to create two different endpoints, a lesson endpoint and then a metadata endpoint. So we're going to jump into creating that lesson endpoint first. What we're going to do is create a matching route that will match this route that we have up here. So we'll do that in our API here. We'll do course /chapter /chapter slug /lesson slug .ts. And we'll want to use this define event handler in there. So now let's go over to Hopscotch and create a new request that will hit this endpoint. We're actually going to be creating a couple different lesson requests so that we can sort of test how we're using this endpoint. So we're going to create a new folder within this. Create our new request. And then here we're going to do API / chapter slug, lesson slug. And I probably need to restart the server here. Oh, I forgot the course in the URL. That's what I missed. There we go. Now we received this back, so we know we've got this hooked up. Okay. I'm going to save this request. And one thing that we need to do first is to grab the chapter slug and the lesson slug from the route. To do that, we use the event context. Every single endpoint gets passed in this event object. And this object has the request and other details about it that we can grab. And most of the time, we're not actually going to deal with this event directly, but instead, there's a bunch of helper methods that we can use to pass this event into and help us work with it more easily. But for this case, it's pretty straightforward, so we're able to just deal with it directly. So now if I hit send, we see that we're getting this string back, lesson slug, and chapter slug. So that's exactly what we were looking for. We're able to grab the slugs off of the route, just like we were with the page routing earlier. Now we've seen how to create a basic server route. And in the next lesson, we will continue this and finish implementing our lesson endpoint. In this lesson, we will continue on implementing our lesson endpoint. So the next thing that we need to do is to be able to provide the course data from this endpoint. So we're not quite at the point yet where we want to integrate the database. That will come later in this chapter. So for now, we're just going to move the course data from the client side to the server. So we'll come into our composables here, and we'll copy that. And in the server directory, we'll paste that in. So this will let us import it. Course data. And now that we have the course data, why don't we call this course instead? We can actually reuse the logic from our route validation in order to find the correct chapter and the correct lesson based on the slugs. So we're just going to copy this whole thing here. We paste that in, but we don't need params here because we have the chapter slug and the lesson slug directly. And instead of returning abort navigation, we can just throw this error directly. Which will do the same here for the lesson. This is one of those cases where it's really, really convenient for us that the same things that work on the client side also work really well on the server side and in our server routes. So this create error method works just as fine in our Vue components as it does or on our server routes. And We don't have to worry about a different method, a different syntax, a different interface. We can copy and paste code around. And if we wanted to, if this logic got even more complicated, in theory, we could refactor this out into a separate utility method that's used both on the server route here, as well as in our route validation. And of course, now that we have found the chapter and the lesson, we need to actually return that object instead of this string here. So we save that, and then coming back over to hopscotch, we'll send this request again. And you can see that we do not find this because we get an error because we do not have the correct chapter. Now, this is actually great because it tells us that our endpoint is working as it should. One thing that's nice about hopscotch and other tools like it is that we can create a bunch of different requests, and we can actually add in our own tests. There's a little tab here that lets us write some JavaScript code that will test the request and make some assertions on the request that or the response that we get back. Now, this, of course, does not replace automated testing, unit testing, integration testing, end-to-end testing, but it is a little bit better than manual testing and makes it a little bit easier for us when we do want to just click around and manually tweak some things and check that things are working the way that they should. So we're going to test this just a little bit just to see how this might work. So I'm going to rename this because we're not getting the first lesson. And I can come in here. There's these little snippets that make it really easy. If I change the size, then we can see what they are. A snippet to check the status code. And we want to check that the status code is 404. So we're actually going to do this. And if we save that and send, we can see in our test results that our test is successful, which is great. And we can add in more tests if we wanted to be more precise about what we're doing here. But instead, now that we've tested the error path, let's create a request to test the happy path. So we duplicate this request and we will edit it. And we'll make this one get first lesson. We'll remove that test because it no longer makes sense. And then in order to get the correct slugs, we can actually just cheat a little bit and grab this URL because we're using the exact same URL format. So I'll do /API and then paste in this route that we copied. And if I hit send, you can see that we get back the object that we were expecting. This is the lesson object that we need. And so one thing that we can do here is actually test a property on the response that we get back. So let's do that. And hopscotch here isn't giving me enough room, so I'm going to decrease the size a bit there. So I'm going to check the title. And I'll just copy this. Hit save, and I'll send that. And if we come over in the bottom here to our test results page, we can see that our test passed with flying colors, Now, we're not quite done with our requests here because we have one issue. If I come in here, let me duplicate this first lesson here. And instead of get, if I change this to a post request, we see that our API responds correctly. But actually, this is not what we want. This endpoint should only respond to get requests. So one way to do that could be to look at the event, check what method it is, and if it's anything other than a get method, we could return an error code saying this is not implemented correctly. But of course, Nuxt has got us covered in that arena as well. All that we need to do is add the suffix .get. And this works with any of the HTTP method types. Once we add in .get and we try and send a post request to this endpoint, we get this error that method post is not allowed on this route. This makes it really, really convenient for us to implement the different methods on a single endpoint. So we can have one file that's for get. We could create another file and implement our post. We could do yet another file to implement the patch method. And so in that way, we're able to very easily separate out our methods without adding any extra boilerplate or overhead. And we don't need this file, so I'll just delete that. And there we are. We have seen in this lesson the basics of creating server routes in Nuxt 3. And we've created our first endpoint, the lesson endpoint. In the next lesson, we're going to take a bit of a detour and update our types so that we can make our endpoints more type safe. After that, we'll handle creating the course meta endpoint. In this lesson, we're going to see how to add types to this endpoint. We created types in a previous lesson for the use course composable. And we can take these and instead move them into this endpoint so that we're able to use those types there. But instead of moving them into the endpoint, we want to be able to use them in this composable as well as in our endpoint. So we're going to create a types folder. Inside that folder, we're going to create a course.ts file. And we'll copy in the types that we have here. We need to make sure to export all of these types so that we can import them into the use course composable. So to do that, we'll add in the export keyword. And then we'll import these types back into the composable. We can do that using this tilde, which references the root of our project. So we do the tilde / types / course. But we actually need to select the specific ones. So we grab lesson, chapter, and course. But now that we're importing these, we need to get rid of the local declaration here. So we can just remove that. And now we've got our types in a separate file. One extra thing that we're going to do to make things a little bit easier for ourselves is create a separate lesson type. One that has the lesson as we get it in the course data, and then one with this path added on. To do that, we'll remove this path property from the lesson type, and then we'll create a new lesson type called lesson with path. And here we can use the TypeScript intersection to take the lesson type and then add on some new properties. In this case, we're only adding on a single property. And what this intersection operator does is it basically just combines the two types together. So going back to use course, we'll also import the lesson with path. And we'll update our composable here to use that. Do lesson with path here. This is technically a lesson, just to be a little bit more explicit and clear in what we're doing here. And we'll also add the chapter type to this one here. It's not strictly necessary, but I like to put it in there just to make it a bit more clear what's going on here. One last thing we need to do is we need to go into this chapter type here. So this lessons property can be an array of lessons, but it can also be an array of this lesson with path. So we'll give this some flexibility here because later on when we go to update our endpoint, we'll need this to work in this way. Now that we've updated these lesson types, I also want to get a little bit fancier with some types and add in a utility type for us. I'm going to put this in a global type file because I don't want to have to import this specifically in each file. And in order to do that with TypeScript, we just need to create a file called global.d.ts. And in that file, we have to export here and then also declare this global namespace. And anything inside this global namespace will be global. And so we're defining a maybe type here. And what this does is it lets us take any other type represented by this T here, and that type could be either T, null, or undefined. And this makes it a little bit easier for us to deal with types where we might have the object or it might be null. So now we need to update the lesson endpoint with all of these new types. So we come over here. We need to first import all of our types. We'll paste in this import for our types. We'll put in this statement which turns our course into a course type. It doesn't actually do anything other than give TypeScript a hint that this object that we've imported is actually of the course type. We'll add the return type as a lesson with path. And then our chapter, we could put chapter here, but the problem is that if we come down here, it will show us this error message. And this message says that we have this whole long thing here, which is basically just telling us the chapter type or undefined. Because TypeScript is smart enough to know that what's returned from this find method could be nothing at all if the chapter was not found. So that's where this maybe type comes in handy. This type is maybe a chapter. And so if we hover over this, we can see that this chapter is indeed a maybe chapter. But then down here, we put this guard up. And so TypeScript knows that this either is a chapter or it's undefined at this point. But we're checking for that case with this if block here. So then now when we come down to this section over here, it's no longer undefined as a possibility. We know for sure that it is a chapter. TypeScript is clever enough to infer that through this logic, at this point in our code, this chapter variable must be of the type chapter because we've already handled that undefined case. And so that's why it's really useful to be able to have this maybe type in there. And we'll do the same for the lesson. Now, if we come down to our return, we can no longer simply return this object because it is of the type lesson. And what we want to return is lesson with path. But that's not a problem for us because we can just add on the path right here. We already know the chapter slug and the lesson slug. And now, because we've added on this property, we've satisfied that type, and everything checks out as it should. So if we come back over to Hopscotch, we can test this out. Once I switch over to the get request here, get first lesson, then I'll hit send, and we will get our first lesson, but we'll also have the path added onto it. And so why don't I just quickly add in another test here to make sure that we do get that path. Give myself some room here. And we'll check body.path to be, and then we'll just copy in this path because we know that this one is correct. We hit send, and we'll come over to our test results pane. And we can see that both of our tests now have passed. So at this point now, we have added our first server route to fetch the data for a specific lesson. And we've also added types to that endpoint so that we can make sure that we are fully typed and type safe and leveraging the full benefits of TypeScript. In our next lesson, we will build the endpoint for getting course metadata. In this lesson, we are going to be creating our course metadata endpoint. So we've already got our endpoint for the lesson itself, but in our app, we also have all of this other metadata that we need to access. We need to know the name of the course. We need to know the different chapters and the different lessons that we have in this course in order to render out this navigation on the left side here. So to do that, we'll create a course metadata endpoint. So we'll open up our folder here, and inside of the course folder, we'll add a new file. And since I always forget what exactly this method is called, we'll just copy and paste it in. Also, I'm too lazy to type, but that's okay. So for this endpoint, we're actually going to start it out the same way we did the other endpoint. And we need to grab all of these different types as well as the course data that we'll be using. Now, what we want to do is provide the course title as well as an outline of all of the different lessons. We don't want to provide the lessons with all of that extra data. We could just take this course JSON here and just return that. But of course, that's going to be way too much data, and we have no real need to send all of that over to the browser. To get started, we're first going to create the types that we'll need. Sometimes creating types first feels like a bit of a chore, but actually it's in a way like test-driven development. It forces you to think about your problem and to deconstruct it and break it down into smaller pieces. And once you've created the types that you need, you know that you've thought through the problem clearly, and then implementing it becomes much simpler. So we're first going to start with the types. Our very first type is the course meta. Now this is the type that we're going to return from this method or from this endpoint. As we said before, we know that we want the title and then an outline, which we'll call chapters. And we're going to create a separate type for us without any of the extra things that come with the chapter. And we're going to call that an outline chapter. To create this outline chapter type, we're also going to create an outline base type, similar to what we did with the lesson and lesson with path. So this outline base type will have the title, the slug, and then the number. If we go into our course types here, we can see that our lesson and our chapter both have a title, a slug, and a number. So these are properties that are common to both the lesson and the chapter, and data that we want to be included in our metadata. This is so that we can have the title here as well as the number in here. And of course, we also need the slug so that we can construct that path correctly. So coming back over to our meta endpoint, we have this outline base, and to create the outline chapter and the outline lesson, we use this intersection operator again. So the outline chapter is the outline base, but with this lessons property on it. And the outline lesson is the same, but it also has this path on there. So now we can start to see the structure of the data that we are returning. We're going to have this chapters, which is an array. And all that that array contains is another array of lessons. So now it's time to actually implement this endpoint. And in order to do that, we are going to make use of the reduce function, which is one of my favorite things. And at the end here, we will return the object, the course meta object. So let's quickly go through what this code is doing. So we have our reduce up here, and we've got previous and next, and then this function here that computes that. We're going to start with an empty array. So the types here actually help us to read the code, because we can see that this reduce is going to return an array of outline chapters. So that means that this here must be itself an outline chapter, or an array of outline chapters, sorry. If you're not familiar with how reduce works, we first start with this initialized array, which in our case is an empty array. And for each item in this chapters array, we take the previous element and we get the next element. So in our case, we're going to start out with an empty array, which we will say is an outline chapter array. And we'll grab that first chapter. Then we compute all the different lessons from that, and then construct ourselves this outline chapter object. And once we have this outline chapter, we can then stick it onto the end of the array and keep going. Then when we get the next item, we have this array, which now has one chapter in it. And then as we go through the array, we keep adding these chapters to it. So how are we computing these lessons here? Well, here we're just mapping the lessons. And what we're doing is really mapping from a lesson with path type to an outline lesson type. So here is where we're really getting rid of all of the data that we don't need. This implementation could have also been done with two maps. If you are using something like Lodash or another utility library, they also have pick methods, and we could be using something like that. There are a lot of different ways to implement something like this, but this is how I have implemented it here. So now let's go over to Hopscotch to see if we're actually returning the data that we think we are, because that's always the important part. So I'm going to duplicate this request. And then I will move it out of that folder, and we'll edit the name. And then we need to edit the URL that we hit. And now we will run this. So the JSON that we get back is the title of the course, along with the chapters, which is an array. We get the title and the slug and the number for the chapter, as well as all of the lessons. But the lessons only contain the title, slug, number, and path. And as we scroll down, we can see that the structure of this data is, in fact, what we were hoping for. Now, in this particular case, the data is actually not a huge amount. So the difference between what this endpoint returns and what our course data file here is not actually that different. But you can imagine that if our text in the lesson is substantial, that this could actually mean a huge amount of data. Are you going to send over all 50,000, 100,000 words of content in a written course, or are you going to just return the metadata? That can be a pretty significant difference. So if we come over to our test results, we see that it actually failed. And that's because the title is incorrect. So let's update that. The title is not the title of the first lesson anymore, but in this case, the title of the course. So make sure to save that. And now our test runs successfully. In our meta endpoint here, we actually don't need these two types here. As you can tell from the syntax highlighting, they're grayed out. So why don't we just get rid of those before moving on? So now we have two endpoints. We've got the lesson endpoint and the course metadata endpoint. And these should be good enough for us to now transition into putting all of our data into a database and fetching it through our API. In the next lesson, we will look at setting up Prisma with our project so that we can then use a database from Supabase, put all of this course data in there, and use the database instead of a local JSON file. In this lesson, we'll begin to look at data fetching in Nuxt. So we spent the past few lessons building out our server routes and seeing how we can do that with Nuxt with all of the different tools that comes with Nuxt. And now we'll be able to create a couple different composables which will let us access that data really easily. In this lesson, we're going to start with the use lesson composable, which will let us access those lessons. So to begin, we'll create that use lesson file. And then we'll paste our composable code in here. Starting at the top, we will pass in a chapter and lesson slug. And this is what will allow us to grab the correct lesson that we're looking for. We then make a call to use fetch. This is the composable that lets us fetch data. And it's very similar to a fetch command, or the fetch command that you're probably already familiar with and using in other projects. But this fetch command is a little bit more powerful, and we'll return to that in a moment. But in this fetch call, we have our URL, which uses the slug for the chapter and the lesson slug. And then from that, we get our data as well as an error object. So before we return from this composable, we check to see if we have an error. And if we do, we can use this create error method, which we are now familiar with, to throw an error. Otherwise, we can simply return this data ref with the data that we've fetched. We'll use this composable in the lesson page instead of fetching it from the use course composable. So first we have to grab our slugs from the route. And then using those slugs, we can then pass them into the use lesson composable here. Now we need to make sure that we're using this await keyword because in our use lesson composable, we are awaiting this fetch command. And TypeScript is giving me an error now because we've already got this lesson variable defined. But now that we're getting our lesson from this endpoint, we no longer need to compute it from this value here. So we'll just get rid of that. And as you can see, as we click through our lesson here, we get the same outcome. In fact, it looks like nothing has actually changed. So to prove to you that we've actually done something useful here, I'll open up the network tab. And you can see that as we click through, we're making calls to our endpoint with these different request URLs. A different URL per lesson. And the response is the lesson object itself. So this is all pretty straightforward, actually. The use fetch composable is really easy to use. So let's explore a little bit more about this use fetch composable. One thing that's interesting about this composable is that it actually automatically will infer the type of the data that we get back. If I hover over this data, you can see that it knows that this is a lesson with path object, even though we've never specified this anywhere. And that's because it knows based on this route, it can match it up to the endpoint that we just created. When we want to type out the route, we have this autocomplete here because, again, it knows the types of the different routes that we have. And these are the only 3 valid routes that we have in our application. Right? So undo this, come back to our code that works. One interesting thing to note about this use fetch composable is that this URL here, while we have used a string here, you can also pass it a ref of a string, or even a function that returns a string, or a function that returns a ref of a string. And if you use a ref here, whenever the value of that ref changes, useFetch will automatically refetch your data for you. So in theory, we could change this from a string to a ref instead. And then in our lesson slug page here, we could create a computed prop that returns a string and then use that computed in this lesson. But I actually prefer this method here. Instead of passing in a generic string ref, we pass in the slugs, and then the composable itself will calculate what that URL should be. In this way, we don't have to carry around this structure for the URL ourselves. It's encapsulated nicely within this composable here. UseFetch isn't the only way that we can fetch data in our application. In fact, useFetch is a wrapper around two other functions that are very useful in Nuxt. So we can create an equivalent version of this using the use async data as well as this $fetch. So I'll save this here and refresh. So you can see that as we click around on the side here, our data loads. And so these two implementations are actually functionally equivalent. They do exactly the same thing, but just with a slightly different syntax of doing it. So let's explore how this works. And we'll start with this $fetch. So this $fetch here is very similar to the fetch command that you are used to. It fetches data from a URL. But this command is isomorphic. And that's a really fancy, cool sounding word, but all it means is that it does the same thing on the client and on the server. You'll notice that a lot of the things we talk about in Nuxt actually do this, including this createError method and many other things, which simplifies our lives a lot. But in the case of the fetch command, we can use it on the client side as well as on the server, and it operates in the same way. Except there's one little catch here, and that is that when we're on the server, this $fetch will skip the whole HTTP request thing. Instead, since we're already on the server, this call here is in the same process as our server endpoints. And so this method here just gets directly called, as if it was just another function in our application. So we skip all of that HTTP overhead, which makes it much faster. One other thing that's great and that we've pointed out already is that this $fetch enables this wonderful automatic type inference. Technically, our server-side routes are running on a separate application on the server, and this fetch command is being run on the client side. And so they're actually two separate pieces of code. And so type inference between the two is not always that easy. And so Nuxt does a bit of magic for us and allows us to get this type inference. So we've explained what this fetch part does. But what about this use async data thing? Well, simply put, it lets us use asynchronous data. So any data that will resolve or that we'll have to wait to resolve. And we need to wrap it in this function because Nuxt needs to manage that and make sure that when we do server-side rendering, and then that gets hydrated and then rendered again on the client, that whole process works cleanly. And we want to make sure that we're doing things like deduplicating HTTP calls, so we're not making extra requests that we don't need to, that we're not making a request on the server and then on the client immediately making that same request, but that we're conserving and making things more efficient. So there's a bunch of different stuff going on under the hood here. But this use async data composable is really just a very generic way of handling asynchronous data. And all that we need is some sort of function, any function, as long as it returns a promise. And so that's what this fetch function does here, is it returns a promise. So we are able to use it in our use async data. And so we've shown that these two things here, use fetch and use async data with this fetch command, are functionally equivalent. So why do we have both of these if they do the same thing? Well, if you think about your applications that you're building, the vast majority of the async data that you're working with actually comes in the form of these fetch requests. And so to make that main use case as easy to use as possible, Nuxt combines these two things into the use fetch command. And so instead of using the use async data with the $fetch everywhere, which is a little bit more verbose, a little bit more complicated, we can just use the use fetch composable. Those edge cases where you're not directly using a URL might come from if you're using a library to fetch data, or you have some other functions that you're borrowing from another project or something like that, where you're not providing a URL directly, but instead getting some sort of promise from somewhere else. And so that's when the use async data composable is helpful. All right, so in this lesson, we went through the basics of data fetching in Nuxt, how the use fetch composable works, how use async data works with the $fetch isomorphic fetch. And we've described a little bit and gone through a little bit how these two things differ and when you might want to use one over the other. In the next lesson, we will dive a bit deeper into data fetching, and eventually we'll also add in a composable to fetch that course metadata, which we already created the endpoint for. In this lesson, we're going to look deeper into this data fetching in Nuxt. We're going to look at some important arguments of the use fetch and use async data commands, such as the key, the pick, as well as we will look at the lazy keyword. So if we come over to our API documentation here for use async data, so remember that use fetch actually wraps around use async data. So these have the same or very similar function signatures. You can see that we get a lot of different options here. We can pass in a server, a lazy, some default data, a transform function. We can give it a pick argument, a watch source, as well as this immediate flag. So there's a bunch of different things that we can do to configure how our data is being fetched. But there's one option that's really important as part of this use async data function here is the key. So if you look in the documentation, what this key does is it lets us properly deduplicate the requests. Now, in earlier versions of the Nuxt 3 beta, they did provide a cache along with this, but that had some issues, and so it was actually removed for the stable release of Nuxt. So to be clear, there is no caching except for on that initial page render. However, that's not really much of a problem for us because we can pretty simply create our own cache. So we're going to do that. We're going to use session storage as our cache. And this is because cache invalidation is a very tricky subject and not something I really want to get into in this course. But with session storage, every new session gets completely wiped out. And so that's a pretty good way of clearing out the cache and invalidating it. So we're going to stick with that. So we'll use the use session storage composable, which works in the same way as the use local storage composable that we used previously in this course. We'll have to make sure to import storage serializers as well as import our lesson with path type. And so what we're doing here is, first of all, we're just sticking this URL inside of a string so we can use it in a few different places. And then we're calling the use session storage composable. We're going to use the URL as the key so that whenever we go to a new URL, it will be a different spot in the cache, so that whenever we go back to the same URL, it will just retrieve that value from the cache. We're going to initialize this with null, and then this option we have to pass in because we're giving it a default value of null. The composable does not know automatically what object type we're going to be giving it. So we're just going to tell it we're using an object, and so when we give you an object, serialize it into a string to save in the session storage, and then when we want to get it back out of session storage, it has to take that string and then convert it back into an object. So if we gave it a default like this, then this is an empty object, and we wouldn't need to pass this in. It would automatically know, oh, this is an object, use the object serializer. But in our case, we want to initialize it to null because that simplifies things for us a little bit. And so then we just need to give it this hint. You'll also notice that we've got these funny little brackets here with the type in here. What this is doing is telling the composable that the type that we're using this with is the lesson with path type. And this is important because then the return type that comes back is a removable ref of type lesson with path. And so these angled brackets are basically, you can think of them as type arguments. So if removable ref is a function, this type here is an argument to that function. So that sets up our use of the session storage. And now this lesson variable here is a removable ref. This is the type that the session storage returns back to us. So if this value already exists, then lesson will be the lesson that we've already got. But if we haven't yet fetched from that, then it will be null. So we need to check for this. And so our use fetch and error handling here needs to be updated a little bit. And so what we're doing here now is we first check to see if we've hit the cache. And if we have a cache miss, then we need to fetch that data. So when that happens, we can call this. And here we're giving useFetch a hint that we are actually going to get back this lesson with path, because if we don't, then because we're passing in URL as a variable, TypeScript isn't quite intelligent enough to know and to infer that this URL is of the lesson with path type. And so because we have this variable here, then we just need to give it a little bit of a helping hand here. And then we've got our error handling as before. And then the crucial step here is that once we've fetched that data, we need to put it into the cache. And so updating this lesson value here with the data that we got back from our API will set the value in the cache. Because remember, this is a reactive ref. And so anytime we update this value, it will update what's stored in the session storage. I've also added a little message here so that if we're retrieving it from the cache, we'll just print out a little message so that we know that. And at the very end, we'll return our lesson. All right, so now let's see this working. So if I go to chapter 1, we see that the request comes through. If I go to chapter 2, that request also goes through. But if I go back to chapter 1, we get no request. And in the console, it will say, we're getting lesson 1 from the cache. And so if we click around a bunch more, we'll see lesson 3 was already in the cache because that was the first one that we loaded. And there we go. And all of this loading here is actually from this Vimeo script. And that's not really anything that we can cache locally. So that will always take a bit of time to load. Great. And so now we've got a pretty straightforward and basic cache for this endpoint. So I mentioned this key value that we have in this use async data. And you'll notice that over here, we're not actually using the key value anywhere. And this is because by default, useFetch and useAsync data will automatically generate the key for us based on the URL that we're using and the position of the call within the code. So most of the time, this does a great job for us. But if you do run into issues where data is being inconsistent, or you're suspecting that this deduplication is not happening, then we can pass in our own custom key. We can also use this pick parameter to only bring us the fields of the response object that we actually want to use. So many times, when we're fetching data from an API, the object that's returned has dozens, perhaps even more data fields. And often we only need 1 or 2 of those fields. And so 80% of that data that's coming over the wire is a waste. And we're wasting bandwidth and slowing down our app unnecessarily. Well, with this pick field, we're able to specify that we only want these 2 fields. And when we're on the server side, this means that the amount of data that we are hydrating with our app is much smaller. And it also means that the data object here is much easier to work with because we don't have all of these extra fields that we don't need to pass around everywhere. So if we save this, and now that we've got cached here, I have to create a new session. You can see that we're loading the number, so this renders correctly, and we're loading the title of the lesson, so this renders correctly. But because we're not loading the video ID or anything else, we're not able to get anything more in our lessons. So not useful for us right now because we need all of the data that we're sending over. But a quick demo of how this pick function works nonetheless. The last option that I wanted to go through of the more important options is this lazy keyword here. Now, normally with this useFetch and useAsync data, we have to put in this await keyword because we're going to wait, and this promise is only going to resolve once our data comes in. But in some cases, we actually want to continue along our execution here. And instead of waiting for this whole thing to render, we actually would prefer to put in some sort of loading state. Maybe that's a spinner, maybe that's a progress bar, or whatever it might be in your case. if we set lazy to true here, we can get rid of this await keyword. And then we can use this pending property, which will tell us if the data is loaded or not. And then you can use this pending property to switch between your loading state and your normal state. And because this behavior is common enough, we actually get a shorthand for this. Instead of needing to provide that lazy true, we can just use the use lazy fetch or use lazy async data. But in our case, we want to wait until that data is fully there, and so we'll use it in this regular way here. And so if we come over here, you can see that we've got use async data, but we also have use lazy async data and then use lazy fetch. And so if you want to check those out further, you can find those on the documentation. Now, before we wrap up with this lesson, I do want to point out one more time, just to make sure that it's super clear, is that this use fetch method is a wrapper around use async data. And so all of the options that we can provide to use async data, we can provide to our use fetch command as well. And because use fetch uses that $fetch under the hood, we also get all of those options as well, including method, base URL, and so on. So now we've seen not only the basics of data fetching in Nuxt 3, but also some more advanced ways that we can control how our fetching works, including how we can build a simple but effective cache on top of our data fetching. In the next lesson, we're going to continue on and finish up our data fetching and fetch data from the course meta endpoint. In this lesson, we're going to take this use lesson composable that we have already created, and we're going to turn it into a more generic composable. So right now, this function or this composable lets us fetch data from the lesson endpoint, but we also want to fetch data from our course meta endpoint. And we'd like to be able to do it in a similar way using this session storage caching layer that we've put on top of this data here. So what I'm going to do is actually to copy and paste this into a new file, and then we'll modify it from there. So now we're working in our use fetch with cache.ts file. Now we're going to work through and make this more generic so that we can use it with any endpoint that we want. So the first thing that we need to do is, instead of passing in slugs here like this, we're going to instead pass in the URL straight up. And we'll specify that that is still a string. Then, of course, we can get rid of that line. And now we're going to rename this lesson here. And we're just going to call it cached, because that's a bit more generic term here. Say cache.value, cached, and we'll return the cached value. We'll update our status message to be a bit more generic as well. And then this message here, when we have a cache hit, will also make this more generic. So now we have a pretty generic composable that we can use with any URL, and it will automatically give us this session storage cache layer. But one issue that we have is that we're still using this lesson with path type. Luckily, TypeScript gives us a way to create more reusable functions using generic types. You can think of these sort of like arguments for types. And so that's exactly what these arguments are doing here, or these angle brackets are doing here. This use session storage is a generic composable, and we can pass in any type to it to tell it what type to expect. And we're going to make our function here work exactly the same. So right up here, we're going to put a t, and this means that this is the type of this function. And then instead of lesson with path, we'll replace that with this generic type t. The name here doesn't really matter. You can name it whatever you want, but t is a common variable name. It's used for this generic type. And basically what this lets us do is say that whatever type we want to use this composable with, we just pass it in here. And then we'll take that type, we'll pass it along to this use session storage. And then this use session storage knows that this cached value here is a removable ref of type t, whatever t happens to be, of course. And our entire function continues on in this way, that use fetch of type t. So we're going to get data back that's of type t, and we continue on. Now in this spot here, TypeScript has a little bit of issues with figuring out what's going on here. And so one trick that we can do with TypeScript is to cast from one type to another. So in this instance, TypeScript doesn't know exactly what type data.value is supposed to be. But from looking at this code, I can say that data.value is for sure going to be type t, because it's coming from this use fetch here. And so I'm basically just going to override whatever TypeScript thinks is going on here and tell it that for sure data.value is type t, so therefore we can set it to cache.value. Now this as casting here can get you into some trouble because you are overriding TypeScript. So if you override it incorrectly, then you're basically shooting yourself in the foot and invalidating all of that value that TypeScript is there for in the first place. Okay, so now we have our cached generic composable for fetching data. Now we need to refactor use lesson to use this instead. And it's actually very straightforward. In fact, what we're going to do is remove this import here because we do not need that. And so the first thing that we need to do is basically get rid of all of this. We do need to create our own URL here to pass in. But we can call use fetch with cache and then use the template as an argument there. Now, this is where the generics come in again. Because we have not provided the lesson with path type, TypeScript does not know what this value is, and we get this unknown here. So just like we did with the use session storage method, where we passed in this type t, we're going to do the same thing here. We can pass in the type lesson with path. And now we're able to infer that this fetch here will pass in a lesson with path, and what we're going to get back is a promise that contains a removable ref of type lesson with path. We can also get rid of that import that we don't need. And we're good to go. Now that we have this useFetchWithCache composable, we can now use it to fetch data from our course meta endpoint, which we'll do in the next lesson. In this lesson, we're going to take our useCourse composable that we have been working with throughout this course, and we will refactor it to use the useFetchWithCache composable that we just created. We'll also have to refactor a bunch of little things throughout our app so that we can use these new endpoints correctly with the rest of our application. So to get started, we're going to move into our useCourse file. And we have a lot of stuff going on here because we're taking this course data and then mapping it and adding different path to it, adding types to it. But now that we're having an endpoint that does this for us, we can get rid of most of this. In fact, this useCourse composable becomes this very simple line here. This is all we need in order to fetch the data from this endpoint. The useFetchWithCache composable handles all of that other stuff for us, except that we need to do one more thing in order to finish this. And that is we need to add the type. And the type here we know is course meta. But we have to import this from somewhere. And currently, this course data type is only defined in this meta endpoint. So what we need to do is pull out these types and move them into our type file that we have created. So we'll grab these and open up our course types file. And then we'll add them in at the bottom here. And then these last ones here, we need to export as well so that we can use them in other parts of the application. Now that we've moved these types out of the endpoint, we now need to import them back in. Now that we've done that, the types in this endpoint should be good to go. And then we just need to import the course meta type from there. And this is all that we need to do to re-implement this useCourse composable. Now that we have this handy useFetchWithCache composable that does some nifty things for us, as well as our course meta endpoint. The next step is to refactor the rest of our application in order to use these two new endpoints correctly. So we're getting data, but we're getting data in a slightly different way than we were before. So that requires us to make a couple little changes throughout the app. First, we'll go with the use first lesson. And one thing that we need to do is that useCourse is no longer a synchronous composable. It returns a promise. And so we need to make sure that we await on this. So we'll add this async keyword to the function so that we can add in this await keyword. And then we are getting a ref back now. So we can't destructure immediately off of that. Or at least I prefer to not do that. And now we add in course.value.chapters.lessons, and this works as it should. Now that we've changed the interface of this use first lesson composable, we'll need to update every instance that we use this composable as well. So we'll first go into our course page here where we use the useCourse composable. And again, we'll add in the await keyword. We'll change this to course. And then where we use chapters and title, we have to update. So we'll put in course.title here. And then course.chapters. And in this component here, we're not using the use first lesson composable yet, but what we want to do is navigate to this first lesson here. So it makes sense that we should, while we're at it, just refactor this part here. Now we've tidied this up nicely. And one thing that's interesting that you'll note is that, yes, we are calling use course in here, and then use first lesson immediately will call use course itself. But because of the caching that we've added in, and the caching that use async data provides, we won't ever make multiple calls one after the other to an endpoint. So that's it for the course page. Let's move on to the lesson page. In this one, we have a few things we need to update as well. We need to put an await on this use course here. And in our middleware, we need to put an await on our use course, which requires us to also make this function async. And now that course is a ref, we need to add .value to this. And lastly, down here where we use the course to find the chapter, we'll add the value in there as well. And in the title. Almost missed that one. The last page that we need to refactor is the login page. So let's head over to that one. Same thing as before. I'm going to do await. Replace this with the course. And then we just need to pop in course.title and we're good to go. The one last thing we want to do before we wrap up with the data fetching section of this chapter is to get rid of this course data file in our composables. Now that our data is all provided to us from our endpoint, we don't need to have any of the data shipped to the client. All of that data can stay on the endpoint on the server. Okay, so we're going to restart the dev server to make sure we've got the latest code changes. And because we've got caching based on our session, we'll create a new session. And as we click around, things are appearing to work as they should. We can log out. It says log in to TypeScript with Vue.js 3, which is the title of the course. So that's great. And something looks like it broke here. Why is this link not clickable? I forgot to update the index page here. Okay. So once we do that, then we refresh this, and now this is actually a clickable link. And there we go. We have now refactored our app so that it works correctly with all the endpoints that we created, those 2 endpoints. So now the data is not shipped with our client bundle, but instead lives on the endpoint. And all of the data that we're accessing, we access through these API endpoints. The next step is now to move that data from our endpoints and move it into a database. So that's what we'll be tackling in the next couple of lessons, setting up our database, setting up Prisma so that we can access our database in a nicely typed way, and then fetching that data from our database in our endpoints instead of using the local files that we've currently been using. In this lesson, we will be setting up our project to use the Supabase database with Prisma as the ORM. So in Supabase, we're going to come over to our database section here. And actually, we need to go into settings at the bottom and then database settings. And we need to reset the database password. So if you were following along with what I was doing earlier when we set up Supabase, we ignored this database password because we weren't using the database at that time. If you've kept that password safe, then you don't need to reset this here, but I am going to reset my password. So we come here, we hit reset database password, and we can specify our own password, or we can get Supabase to generate a secure password for us. So I'll get Supabase to generate that for me. Then I'm going to copy that and just keep it somewhere safe. So for now, I'm just going to paste that into a new file there. And we hit reset, and it will reset the password. So we need to reset this password in order to allow Prisma to connect into our database. Now that we've got the password, let's take a little look at Prisma. So if you aren't familiar yet with what Prisma is, basically what it lets us do is write one schema that's used in both our client-side app and in our database. So if you're creating a database with SQL or anything like that that uses a schema, you have to define every single table and the different columns in that table, what their types are, the relationships between those columns, and all of that good stuff. But then in our app, we've also defined TypeScript types so that we have that data when we're developing our JavaScript app. Now, this can become a bit of a pain because we actually have two schemas here. We've got this TypeScript schema for our application, and then the schema in our database. And what Prisma does is instead we define one single Prisma schema, and from that, Prisma generates all of the TypeScript types that we can use in our application, as well as the database schema. So this ensures that everything is kept up to date, everything is all synced together, and that we are able to develop without any issues. And Prisma also handles things like migrations, seeding the database with dummy data or default data that your application needs in order to function. And so we're going to see that later on in the next couple of lessons as we go through setting up Prisma. So now we're going to set up our VS Code environment to make it a little bit easier to develop with Prisma. One of the first things is to install the Prisma extension. So this adds all sorts of syntax highlighting. It adds linting. It does code completion, formatting, very intelligently does formatting, which is very nice. It will autocomplete things to make sure that you're not missing different parts and that your syntax is correct. And so this is actually a very helpful extension. So install that. We're also going to update our workspace settings so that we can use the Prisma formatter that's built in so that we can get all of this formatting. So if we come down here to the formatter section, it tells us how to update this in our VS Code settings. But one interesting thing that we can do is instead of saving this to our user settings, we can save this to the workspace settings so that these settings live in our project. And this is really cool because it lets us work with other people more easily, especially if we are doing formatting like this. We don't want one person to format the code in one way and then have it be reformatted in a completely different way when we use it. So by putting these settings into the workspace instead, they live with the project, and so the formatting will be consistent. Assuming, of course, that everyone is using VS Code. If you do Command, comma, this will open up our settings. And instead of doing the user, we'll just head over to the workspace. And I'm going to search for format. And then I'll enable this format on save here. Now I also want to add in a custom section, and I need to have access to the underlying JSON file. So in order to do that, we can open up that JSON file. So now that we've edited this option here, you'll see that VS Code added this VS Code folder. And inside of that is a settings.json. This JSON has the format on save option. So this will ensure that when we save a file, it will automatically format it. Then we'll need to add another option. And what this one is telling VS Code is that for Prisma files, we're going to set the default formatter to the Prisma formatter. So now when we edit our Prisma schema, it will use the Prisma formatter to tidy everything up for us nicely. So now we're going to set up our database URL environment variable. And this is where we will use that password that we saved just a moment ago. So in order to get that database URL, we'll have to go over to our Supabase settings here. And when we scroll down, we see that we get the connection string here with a bunch of different options depending on how we're connecting to it. But you'll also see that below that is this connection pooling section here. And what connection pooling does is instead of creating a new database connection for every single request that comes in, it will instead create one request or one connection and then reuse that connection over and over and over again. And as your application scales up, you can add more and more connections to that pool. And so this reduces the load on your database and generally improves the speed and performance of your application. Now, for our purposes, we don't really need this, except that we're deploying to Netlify. And Netlify uses Lambda functions, which are serverless. And so with serverless functions, they are spun up and spun down for every single request, which by default would create a new database connection for every single request that comes in, which is not what we want. So we need to use this connection pooling setting in order to force Netlify to reuse that same database connection over and over again. So we'll come down here and we'll copy this string and we'll paste that underneath in here. And right where it says your password, we're going to copy this password into that. But then we also need to append this query string at the end. So this query string tells Supabase that we're going to use PG Bouncer for the connection pooling. And we're going to limit it to a connection of 1. There is more information on how to use Prisma with Supabase. So they have written docs specifically for this. And so if you want to do a little bit more reading on how this works and how we've set this up here, you can go to that. We'll include the link in the description of this lesson. So now we have this URL. We need to add this to our environment. But the key thing here to remember is that we only need this for Netlify when we've deployed. When we're developing locally, we don't need this connection pooling. And in fact, when we try and do migrations and get Prisma to update and work with our database, it actually breaks that functionality. So we want connection pooling when we're deployed on Netlify, but we don't want connection pooling when developing locally. So to do this, we'll go over to Netlify. And now that we're in Netlify, let's go to our site settings and we'll come down to the environment variables section. So what we want to do is, let me first delete this out. So we have our Supabase key and Supabase URL that we have added in previously. But what we can do is add from the UI here instead of the command line interface. We need to give this the name database URL so that Prisma can pick it up properly. And what Netlify lets us do is specify what values are used in what scopes. So if we're developing locally, we can have one value for that environment variable. And then once we've deployed, we can have a different value. So that's exactly what we're going to do here. For production, we're going to paste in this value here that includes our password and the connection pooling string. But then for local development, we need to come over to our database settings here, and we'll just grab this URI here without the connection pooling. We'll need to make sure to copy our password into this one as well. So it is a slightly different URL if you look at it. We're using a different port for the connection pooling versus no connection pooling. And so we want to make sure that we're using the correct one in the correct spot. So we'll paste that into the local development here. If we take a look here, we can see that we have our production value set and our local development value set, but no value set for deploy previews or branch deploys. So I need to go and fix that because we want to be able to preview our deploys as well. There we go. Now it shows that we have a value in all 4 of these places. We've got 2 different values in 4 deploy contexts. So we're good to go. Except we don't have that database URL in our .env file yet. So if I'll come over here, we can see that all we have currently is the Supabase stuff. So one way that we can get this variable in is by copying and pasting since we have it over here. But normally we would not have access to these variables. They would only live in Netlify because we want that single source of truth that's going to be password protected and going to keep our secrets nice and safe. So one way that we can get them is using the Netlify CLI tool. So if we run this netlify env command, you'll see that we also have this get. And so if we do database URL, then we can grab the value that we have set here. And notice that this is missing that connection pooling string because Netlify is going to pull only the local development one, as you would expect. So now we can grab this environment variable here, and we'll add it into our environment variable. And with that, we have done all of the boilerplate setup that we need in order to start working with Prisma, which is what we will tackle in the next lesson. In this lesson, we're going to create the Prisma schema, and then use that schema to then generate the database schema and our TypeScript types. So we'll first start by creating a Prisma folder for ourselves here. And we'll put everything in this Prisma folder related to Prisma. So the first thing that we need to create is this schema file. We need to call this schema.prisma. And once we've got that, then we can begin setting up our schema. The first two blocks have nothing to do with our app at all, or nothing to do with the types in our app, but rather are there in order to scaffold and configure our Prisma project. So the blocks are pretty self-explanatory. The first block is describing the database with the URL to that database, and then what type of database it is. In our case, a Postgres database. Then the next section describes what we will be using this Prisma types and schema with. So we need to put this in here because Prisma is actually able to generate clients for many different languages. So we can specify different providers for different languages in here if we wanted to generate clients for multiple languages. We're also able to add in some other options as well and do some configuration, which we don't need to do yet. So if you're on Apple Silicon, you might need to add the binary targets here to the generator so that it generates the correct type of client. And if you're using PNPM like I am, you'll need to specify the output for this client. The reason for this is that because we're doing PNPM with Nuxt 3, we have to include the shamefully hoist option with the installation. And so then the structure of the node modules folder is a little bit different than what Prisma is expecting. So this just gives it another hint so that it ends up in the right spot. So now that we have our basic setup done, we need to add in the different types. In Prisma, they're called models, and they map directly to database tables as well as the TypeScript types. So our first model is the course model. In it, we have the ID, the title, just as we have in here, in our course, we have a title. And so we're adding in this ID so that we can reference this course uniquely. We'll also add in the created at and updated at field. These are really useful because we can easily see when this object was created in the database and the last time it was updated. You'll also notice that we've got some of these attributes here. And so these map to special meta info about the object that our database will use, and Prisma will also use in our TypeScript client. So ID specifies that this field here will be used as the ID property. And this here specifies that by default, we are just going to auto increment this. So we'll start with 1, and then for every course that we add, it'll auto increment it. If you are familiar with SQL or SQL, then these will look familiar to you. So created at, by default, it will use the current time, and then we'll use this special updated at attribute for updated at. Our chapter model is very similar. We've got the ID, we've got created at and updated at, as well as the different fields in our model. And lastly, we'll add in our lesson. Now this one has a few more fields, but the format is the same as the other ones. The only interesting thing to note here is that this string here is optional. So we have this question mark, just like we would see in TypeScript. That question mark lets us denote that this field is optional. So if we come back to our course file here where we define the different types, you can see that this maps pretty closely to what we have got here. The only difference is that with our course, we have chapters, which includes the chapter type. We have lessons, which includes the lesson type. And so what we need to do next is to define the relationships between these different models. So in our SQL database, we would be able to define relationships using foreign keys that reference the ID of other tables in the database. In Prisma, these are called relations, and we can define them by using these attributes. The only difference here in Prisma is that we need to define that attribute on both models, whereas in a database, depending on what the relationship is between the two tables, you may only need to define it in one table. So if we wanted to add the lesson relation to our chapter, we could add this lessons here. At first it gives us an error, but then when we save it, it will actually auto update. And we didn't see this because it was scrolled below out of view here, but it adds in this chapter and chapter ID field. And so what this is saying is that every lesson has a chapter, and we'll include the chapter ID in the lesson table. Now, up till now, we've been sort of thinking about it as each course has a bunch of chapters and each chapter has a bunch of lessons. But saying that a lesson belongs to a chapter is the opposite way or inverse way of saying that a chapter has many lessons. And so that's exactly what this database is doing, in that each lesson has a field on it that specifies which chapter it belongs to. In our database, there is no field for this lessons here. In addition, this chapter object here does not exist in our database. This is just a Prisma thing. So this lessons here is just for Prisma, and this chapter object here is also just for Prisma. And this relation attribute, what it's doing here is saying that this chapter ID field here references the ID on our chapter, so that we know that this chapter here is actually linked to this ID. And so in that way, in our database, every single lesson object will include a chapter ID that links to a specific chapter that it is a part of. And then when Prisma fetches that data, it can tell which chapter each lesson is a part of. And it can also do some really nice things for us that instead of requiring us to figure out and put this data together, when we grab a lesson object, we'll also be able to grab the chapter object. And so that's why this is here. This is only a Prisma thing, but it's there because it makes our lives a little bit easier. So although it auto-completed it for us, it's actually a little incorrect because these relations are not optional. So we'll remove those question marks, and now that's correct. And we have only one other relationship that we need to add in, and that is from the course to the chapter. So each chapter contains a bunch of lessons, and each course contains a bunch of chapters. And again, when we save, it auto formats this and adds in this relation here, but it is not optional, so we'll just clean that up. And now our schema is complete. If you want to learn more about schema in Prisma, I highly encourage you to go to their docs. They have a very in-depth and well-written documentation that explains a lot of what's going on and how it relates to TypeScript as well as the underlying database schema. It's also useful to read up on SQL and database schemas in general if you want a deeper understanding here. But since this course is about Nuxt, we won't go into that any more than this lesson. So in our next lesson, we'll be taking this model and initializing our database and then seeding it with the course data that we need in order to use our application. In this lesson, we will be finishing up our setup of the database with Prisma. So we're going to be doing two things. The first is initializing Prisma and our database. And then the second is adding in our seed. And so this seed data will be the course data so that we can actually use our application and we don't have this empty database that's completely useless. So first we're going to install Prisma. Do that with pnpm add-g Prisma, which will install the CLI tool. We'll also want to install the Prisma client itself. Now, what Prisma does is actually pretty interesting. So instead of installing a client that everyone uses, what it actually does is it takes this client that we just installed, and with the CLI tool, it will go through our schema and generate a custom client library. And this library includes all the different types that we have so that it's developed specifically for our application. So if I run Prisma generate, then we can see that it has generated our client to this location here where we asked it to in our schema here. So it's in node modules and then a .prisma folder. So it means you have to scroll all the way to the top here. There we go. It just wasn't scrolling up. That's what I was missing. So here we are in our .prisma/client folder. And so it generated this file for us. And so this isn't actually important for us to understand or to see, but it is interesting to know that when we come in here, it's going to generate this for us, and it's all custom based on our application. So you can see that we've got this chapter with all the different fields from our chapter model, as well as our course model and our lesson model here. Ooh, okay. Yeah, the lesson model here. So it custom generates this for us. And so that's an interesting way of getting around this problem of creating types from our schema. So by doing this, we have access to all of these types. But what this also means is that every time we change this schema, we need to rerun that Prisma generate so we can generate a new client for us to use. Okay, so now we have our Supabase database set up. We've got our Prisma schema set up. We have our Prisma client generated. But if we come over to our Supabase project, and we open up this table editor on the side here, you'll see that there are no tables available in this schema. So we haven't actually done anything with our database yet. In order to do that, we run this command, Prisma migrate. And there's a few different commands off of this migrate command. We can use a reset command, we can use a dev command, and a deploy command. So reset will reset your entire database. And this is useful in development if something got messed up with your database, or you just want a fresh, clean start. So that's pretty self-explanatory. Then dev is what we want to use in development, and deploy is for when we've deployed our application. So we would run deploy on a continuous integration server where all it's going to do is update the database. What the dev command does is actually a bunch of extra stuff to make sure that our database is going to work properly. So it does things like making sure that the migrations are going to be consistent, that we haven't done anything weird with our Prisma schema that's going to break anything. And it does this with some fancy stuff. It creates a temporary database in the background and runs some things against it. But really, the important part here is that it generates the migration and then runs it, whereas the deploy command only runs the migration. So if I run this command, we'll see it generate that migration. So we have to enter a new name for this. We'll just put init because it's the first one. And it tells us that it's created this migration in migrations folder. So if we come over here to our file explorer, we can see that it has created this migration. So what is a migration? Well, it's a SQL file here. It's a SQL file that contains all of the instructions to run against the database. So you can think of migrations as git commits for your database. It keeps everything in sync. And if you need to reset your database or do any changes to it, it keeps track of that in a really straightforward way. So Prisma generates all of this SQL for us, but you can see that it's creating the chapter table, creating the lesson table, and doing all these different things like linking the lesson to the chapter and all that kind of stuff here. And so this is important because the migrate dev command will create this migration. And then once you know that this migration works and is correct and isn't going to break anything, then on your continuous integration server, the migrate deploy command will simply run this migration against your production database. Okay, so we've run that. And so if we come over to Supabase now and we refresh, we should see our tables in here. Yes, so we've got all the different tables. And they have all the different columns here that we were expecting. And Prisma created a fourth table for us. And basically what this table does is it keeps track of which migrations that this database has performed already. So this is useful because you might have different databases in development, in staging, in a testing environment, and in production. And you want to be able to know which migrations have been run and which haven't yet. And so this is also useful for resetting. You can do things like rolling back a migration and then reapplying that migration. If something kind of went janky, then this table keeps track of all of that for you. So you don't have to worry about it. And Prisma will handle all of those details. Okay, so now we have our database and it's set up, but it's completely empty. Obviously, this is not helpful to us because we need data in our database if we're going to use it at all. And in our case, we need all of that course data in the database. In other applications, you might have default data in the same way, or you might just want to have some dummy data in this database for development purposes so that when you spin up a new dev environment, you have some data to work with so you can start playing around with the application and developing it. Prisma makes this really easy, and it has a seed feature built into it. So basically, we need to add this field here to our package.json, and then we create a script that will then be run by Prisma. And this script will use the Prisma client to add data to the database. Then Prisma will automatically run this seed function or this seed script whenever we reset the database or initialize it or anything where we might need that seed data. So we're going to create our seed file in the Prisma folder. So we'll call it seed.js. And this basic function here, what we're doing is we're going to call this seed function, which is an asynchronous function. We're going to wrap this in a disconnect so that once this is done, or if it errors, we're going to disconnect from Prisma. And then we'll use the Prisma client in this seed function in order to generate all of that data and add it into our database. In order to generate data, you can use a library like Faker.js here, which gives you a whole ton of different objects that you can randomly generate addresses or images or different kinds of animals. You can randomly populate colors, all sorts of things. Basically, anything you can imagine is in here. And this is great for dummy data in tests or to just get something to use in your application so you can, start working with it. In our case, though, we actually have something a lot easier, and that is this course data.json that we actually have been using so far. So we could, as described in the docs here in the Prisma docs for seeding a database, we could go through each individual object type, course, chapter, lessons, and then generate each of them individually. But we can also just pass in a JSON blob, and Prisma will automatically create those nested objects for us. So this is copied straight from the course data.json, but I've had to actually add in a little bit of some changes here. So when we get to the chapters here, instead of putting in this array directly, we have to nest it inside of this create so that Prisma knows to create all of these objects as well. And then when we get down to the lessons, a similar thing, we need to create each of these individual lessons. And we're actually not using this course value, so we can just get rid of that. And so now we have our seed script. If we wanted to, we could get fancier with this and we could combine this with Faker. We could create dummy data for our text, video IDs, URLs, all that kind of stuff. But we already have this dummy data, so we'll use this. The next step is to go into our package.json file. And we need to add a new Prisma field here. And this is what Prisma will look for when creating the seed data. And it will run this command to generate that data. Okay, so now all that we need to do is run that seed file. And if we do Prisma migrate reset, it'll completely reset and then reapply all the migrations to our database. So in this case, it resets it, completely blows away everything we already have, which is nothing. And then we'll seed the database once it's gone through all of the migrations. So we'll say, yes, we want to lose all our data. And it has been successful. Now, if we refresh, we should see all of that data in the database. Okay, so if we look at our chapter table, we can see that we've got all 3 chapters here. We can see that we have this foreign key that links to the course ID because they're all part of the same course, so they're all going to be 1. We can actually click on this and it will take us to the course, which is TypeScript with Vue. So if we look at this course table, we can see that we only have 1 entry in here because we only have 1 course, but we can add more if we needed to, and we could expand this application to have multiple courses. Similarly, we have all of our lessons in here. The IDs are unique, numbered 1 to 11. We've got the titles and the slugs. We've got the number. So this is the number within that chapter. And then if we come over here to the chapter ID, we can see that they're linked to the different chapters that they're a part of, chapter 1, chapter 2, and chapter 3. So now we have our data, and in the next lessons, we'll be able to rewrite our endpoints so that instead of fetching the data from a local JSON file, we'll actually be fetching the data from this database. In this lesson, we're going to take a look at how we can get data from Prisma. So we've got our database set up and we have data in the database now. So the next step is to actually query that database and get data back from it. So we're going to refactor our lesson endpoint. And so we'll open that up here. And we don't actually need most of this. So we'll get rid of all of that. And I'm going to copy in this code here. So our new endpoint, we import the Prisma client. Then we create a new version of that client. And then inside of our event handler, we're going to grab this chapter slug and lesson slug, which we don't need quite yet, but we will in just a moment. And just to test it out and see that it works, we're going to first find that first lesson. So whichever lesson shows up in the database first, we're going to grab that. So to see these requests, we're going to come back to our hopscotch. Going to open up our mastering Nuxt folder here. Lesson, and come in here and we'll hit send. And our result over here is indeed the first lesson. And you know that it came from our Supabase database because we can see the created at, updated at fields, as well as the chapter ID and this ID here, which are not part of the JSON file. And we're not including the JSON file in here at all either. So that's just one method that we get off of this prisma.lesson object. And there are many, many more. So let's take a look at the documentation for Prisma. And you can see here that we have a lot of different CRUD methods for create, read, update, and delete. If you can see here on the side, you can see we've got a lot of different options for querying our data. We can create a single record or multiple at the same time. We can get by the unique ID. We can get all things in a database table. We can filter based on different queries. We can do all sorts of different things. We can select different subset of fields. We're going to go through a bunch of these different things. So we can update, we can also delete. So that's important to know. So the next thing we're going to look at is this find many. And as you would expect, when we query that, it's just going to return all of the lessons. If we want to be a little bit more specific on which we want, we can use this where clause. And let's say we'll put in chapter slug, chapter slug. If we capitalize that, then that's what we need to get that type to work correctly. So we save that and we'll run this again. And what we get are actually just 3 lessons. And these 3 lessons are all part of this first chapter. So in this way, we're able to filter which lessons we get, which objects we are returned from this endpoint. And if all we need is a certain subset of that data, we can put on this select clause. In this case, we're going to just grab the slug of each lesson. And there we get back a much, much simpler array of data. If we want to have Prisma not just find the lesson, but also include the chapter object, we can include it in the request. So we can include these nested objects. So if I run this, you can see that for each lesson in the first chapter, it also includes the chapter object nested inside of that. Now, for this particular query, this doesn't really make a lot of sense because we're just repeating this data. But if we change this to find first, for example, then instead of making multiple queries to fetch the lesson and then fetch the chapter, we can do it all in one single request. And our queries here can actually become very complex because we can nest these different clauses within each other. So if we want to include, let's keep this first query here. If we wanted to include the chapter, but we didn't want all this extra data, if all we wanted were the slug and the title of this chapter, we could change this Boolean to an object and put in a select clause that we just saw, set slug to true, and set title to true. Now when we come over and query this, we'll see that this is a much simpler object in here. So this is just a pretty quick overview of the different kinds of things that Prisma lets us do. It's a pretty simple, straightforward interface on the surface, but it does give you a lot of power and expressivity to sort of change how you want to get your data. So you can nest things, you can do all sorts of stuff here. So it makes it really powerful. And I highly encourage you to check out these docs and see all of the different things that you can do with the Prisma client. In the next lesson, we will be refactoring this lesson endpoint further and finishing it up so that we can return the correct lesson from this endpoint. In this lesson, we're going to finish refactoring this lesson endpoint to fetch the correct lesson from our database. So we've mostly got what we need here for this endpoint, but we don't want to find the first one. We don't want to only look at the chapter slug, and we do not need to include this whole chapter in here. So we're going to get rid of that part. And we're actually going to introduce another field here in the where clause, and that's going to be the slug. So now what this method is doing is finding the first that matches these 2 parameters. The slug of the lesson must match lesson slug, and the slug of the chapter must match chapter slug. If we come over to Hopscotch and run this again, we can see that, in fact, we do get the correct lesson here. But before we had error handling in this endpoint, and so we want to add that back in to this endpoint now. So we'll add an await here. We'll put in an error handling block here to check if we've actually returned the correct lesson or a lesson at all. And then we'll finally return the lesson at the end of the method. So we'll double check that this endpoint is still working correctly. And then we'll go to our chapter not found, where we query for a chapter slug and lesson slug that do not exist. And we return a status code of 404. So that's perfect. But now that we've updated this endpoint, we also need to update the useLesson composable that fetches from this endpoint. We need to update it because this type here is no longer correct. We're getting this lesson back, but it's no longer the same lesson type. Instead, we need to import the lesson type from Prisma. But one thing that we are missing now is that this endpoint does not return the path that this lesson has. So before we were adding the path on, because we're not saving it in the database, and it is missing from this object. So we need to go and add that on right now. So we'll come back to this lesson slug here, and at the end, we'll add this in. We'll copy over this path, which is not quite the same, but almost the same. And now we're returning the lesson with the path. But this presents an issue to us because this lesson type here that we get back from Prisma does not have a path on it. So we're going to go back into our course types file here where we've defined all of these different types. And we're going to redefine what this lesson with path type is. And to redefine it, we're simply going to import the lesson from Prisma and use that as the base instead. Now, if we go back to our useLesson composable, then we'll actually change it back to what we had before. So we've gone a little bit in a roundabout way here, but we now have the correct types because this lesson with path has the correct lesson type from Prisma, which will stay in sync with our Prisma schema and our database schema. And then we add that additional path field on top of it. So if we come back to our app, we'll give it a refresh to make sure that we're using the latest code. And sure enough, everything works as it should. So in this lesson, we finished refactoring our useLesson endpoint to get data from Supabase through the Prisma client. And in the next lesson, we'll do the same for the course meta endpoint.